Zawlbuk Zirna run 10 NEET 2024 question kan ron analyze le dona tuna hian chemistry kan ti chan dona karon chan ma saber dona tuan question tuna code kan man tur hi S1 ani a code sang sanga a oma wang khanin en sol palte hla oma chu wang chuan S1 question ron chang question in the dan milin tuna mi hi chu aron om dona ne kan question number ron pek hi chuan ka thei chen chen karon analyze sanga ka dota sar sai te misma dini le sar twang te ten aron ti ve don ani question number somnga le parukna arrange the following elements in increasing order of first ionization enthalpy ron dia lithium beryllium boron carbon le nitrogen ti aron da a question hi inorganic atanga chhuak phei hi chu aron ole me maya simple ve loma chuan tuna question kan hmu po khi second period tara tanga ron chhuak ania simple maya ionization enthalpy kha first second le third kan neya class a khan kan zirna se maya enge ionization enthalpy kan han ti phot chuanin outermost cella electrons te remove na kan energy sen ngai zat khani tani chuan hei hi kan han ti sin anga lithium kan neya beryllium ron pe a boron ron pe a beryllium ron da a carbon omle boka nitrogen emite panga hi aron da tara an electronic configuration kan jia kanga chulai tang chuan ionization enthalpy chu chiang mai don ani 1s2 2s1 1s2 2s2 1s2 2s2 2p1 1s2 2s2 2p2 1s2 2s2 2p3 chuan ionization enthalpy shim kha trend periodic table a trend chu phezonga kan kal khanin across a period a khan a increase a tiswanin down the group a khanin a decrease ve thunga ni chuan hei en phei taila lithium beryllium in the dan in periodic table in the dan zokin zia lithium beryllium boron carbon le nitrogen ti an lo om ta a tiswanin phezong in hei a in adik patin aron data ne chua hetia phezong adik pata aron da sa hi phezong hianin a increase chuanin asang ber tur chu nitrogen adota carbon boron beryllium le lithium te an lo ni ta ni amero chu exceptional case kan nei lai te kha kan tum bera chu hetilai upon bera electrons remove nana kan energy sen ngai zat khani ta a beryllium le boron hi kan en chuan beryllium a hian 1s2 2s2 s electrons a pahni a khata ni ti chuan boron a ve thung hi chuanin p in a to pa p a electrons pakhata oma han en wangwang ta ilangin atrin kan zir dana chuan phezonga increase awangin boron sangjok boron khi sangjok turani a mero chu helaya beryllium electrons pahni a omawang le boron electrons pakhat om hi kan han khai khinanga he beryllium hi ionization enthalpy kha lo sang don ta ni chu wang chuan helai boron le beryllium lai te hi thak theng nga ya chuan kan trend om thei tur chu lithium asang beranga adota boron adota beryllium carbon nitrogen in akal don ani helai te hi thak theng tur khi kan chan swal pal hlo kha hlo om ta helai hi thak theng na lai tur chu aron da kan answer tur chu option number 3 khi ni don tinani next kan kal le nga langa question number somnga le pariat na match list 1 with list 2 aron ti a quantum number aron pe a quantum number pali ichuanin a information ron provide khile lama khen aron da buka shape of orbital size of orbital orientation of orbital le orientation of spin of electrons ti khiron da quantum number hi chili kanzir chiang hlo me maya information provide thone te khan an han ziak chinanga quantum number pali kan nei ti chu principal quantum number denoted by n kan neya azimuthal quantum number L kan nei le a chuanin magnetic quantum number ML kan nei a spin quantum number MS kan nei le a electron stan khan quantum number pali kan zira heng te hian min shil ai nang lo thewa principal quantum number chuan cell kha min shil ta ni cell kha eng cell nge n hian 1 2 3 4 tuk theya a cell te chu KLMN in an vua theya 1 2 3 4 and so on kha ni ta ni chuanin electronic configuration kan zia 1s2 2s2 2p6 kan tia hetilaya 1 2 2 ma a number ron omzel hi principal quantum number kha ni ta ni chuan 1s hi tuna ziak ta ilangin heti hian ka ziak dona 2s ka zia le don chuanin 1s2 le 2s2 2s ka zia thlen don chuan ti khan point ni ka thaya nga heta hianin 3s2 ron om le ta silangin cell pathum thleng hetia ziang ngai ta ni chuan he hian cell ba ka hian enge min shil kan ti chuan kan en wang ta ila 1s a chuan he a size heti tia thi ni ta ni he hi 2s a lo ni ta a he hi 3s a lo ni ta n equal to 3 a khana lo ni ta ni hey a size alen zong hi min shil thei min shil tel ta ni alen zong a size min shil ta ni n hian cell ba ka khan chuan L a kan kal lenga L azimuthal quantum number a hianin subsidiary quantum number pon ti a orbital angular momentum pon ti a L hianin min shil chu cell mi to lo hian a ai chung ril le subcell kan ti kha min shil ta a om zia chu 1s2 2s2 2p6 ti kan zia hianin 1s he hi subcell ti nani 2s he hi subcell ani a 2p he hi subcell an ni chuan subcell ina min shil ba ka hianin poimo deuh chu s chu engsem nge ni ang spherical alo bel don ta ne p ron lang to a p khi engsem nge kan ti chuam dumbbell shape kan tiang kha lo ni le ta a mi pa ho het a an choi chin ang kha chuan d alo om le a d chu double dumbbell shape kan tiang kha lo ni le thei don ta ne chuanin a shape min shil tel ta ni L hian chuanin shat polo ol mai hemi n le L hi L n zok hi chuanin a size hemi len zong min shila L ve thung chuanin a shape kha min petel thei ta ni chuan ml a kan lut lenga ml hian a behavior te a orientation of orbitals te kha min shil ta ni ml ve thung hian orientation of orbital kha min shil ta ni ml khan minus L atanga 0 atanga plus L thleng a value kha om chho thei ta a chuanin ms ve thung chuan hemite quantum number pathum hi orbitals dan chuan a tok to amero chu electrons kan soidon khanin electrons elaya orbital pakhata hian electrons pahni alenga helai electrons pahni kan dalu tur hi hoizong in ang lawa omangai wangin khimi tan khianin spin quantum number khi kan zir tel lo ngai ta a electrons pakhat khi clockwise zong in akalanga pakhat khi anti-clockwise zong in akaldona emi min shil tu hi ms a orientation na raw khan a spin clockwise le anti-clockwise ani ti min shil tu kha pakhat hi minus half pakhat hi plus half ti min shil tu kha ni ta ni quantum number pali te kan han shil fiam ma sa de lok ani di chuan han kalta ilangin n atang tanang n hian min shil chu nge kan ti kha n in min shil chu a size min shil ta ni principal in min shil chu size d2 omna zong tai le hei pakhat chia om kan answer kan nei thei nga la ni pakhat kan chia da tang hian l2 a shape c1 ms2 spin kan ti kha ni ta hei helai hi ni a ml2 orientation min shil tu kha lo ni le ta a hei ni le ta ni kan answer tur chu number 3 na lo ni le ta ni structure of atoms atanga ron kal ani ta ni hei hi class 11 le khabu structure of atoms quantum number atanga ron kal khani adot le kan kal lenga Given below are two statements. Statement pahni aron da in statement tinge kan siarang statement 1 na hian the boiling point of hydrides of group number 16 elements follow the order H2O, H2TE, H2SE le H2S aron da statement number 2 na hian on the basis of molecular mass H2O is expected to have lower boiling point than the other members of the group. But due to the presence of extensive hydrogen bonding in water, it has higher boiling point. Aron tia 1 le 2 ki adikem dikha enge dika diklaw kan chana tur kan en tura ni tani P block ka aron kalan ni group number 16 chalcogen sa aron kalan ni tani group number 16 chalcogen sa aron kalan ni to tinge group number 16 to oxygen te sulfur te selenium te tellurium te polonium te hi group number 16 te chu ni tani this one he group number 16 te hi hydrogen ne na kan react chuan hydrogen ne na kan react chuan in hydrides aron chuak don tani hydrides aron chuak don na reactivity towards hydrogen kan siam chho tur chu formation of hydrides aron chuak don ani hydrogen ne kan react ang water kalo nei ta dot le H2S gas kan nei dot le H2SE dot le H2TE H2PO question khan helai thleng hi ron pe TE tellurium thleng hi ron pe chuan hei kan lo nei ta ni chuan question ni na aron da lan kha boiling point ani ta ni boiling point boiling point aron zota en wangwang ta ila he water molecule hi akhai khom tu aphuar khom tu kha hydrogen bonding him in kara khian hydrogen bonding aum ta ni water a khian chuan adang zong heng howa hianin intermolecular force kha hydrogen bonding ni ve to lovin hetilaya hianin van der Waals force weak force kan ti kha ta ni khitilai khian weak force kan ti kha a oma adang ho zonga hian heta ve thung hi chuan hydrogen bonding a ve thung ta ni chuan he van der Waals force kan ti hi helaya molecule size alena piang hian a increase ve bokani helaya molecular size a size alena piang khian alian thatu tulta size ki alen kha khian a van der Waals force po kha a increase ani chu chuan boiling point hi it increase bok tani boiling point hi increases bok omja chu down the group boiling point increase tinani chu boiling point increases down the group boiling point chuk zonga increase on tunge boiling point sang berang aron pe ka tanga kan te chuan H2TE adota H2SE H2S le H2O nyam ber turani amero chu H2O ki exceptional case in H2O ki hydrogen bonding aom the wangin a boiling point ki aron sang fal na chu wang chuan hei hi number 1 da turani chuan adot le a boiling point sang le ber tur chu H2TE adot le a chuan H2SE tu boiling point nge nyam berang volatility sang ber ve thung tur kha hei hi boiling point nyam ber don H2S gas kha chuan kan option kan in tai la hei ziak shim ta ina tunge boiling point sang berang H2O boiling point na sang beranga adota H2TE adot le a H2SE boiling point nyam ber tur chu H2S chuan a in mil ta em question ning khan en ta ila H2S boiling point na sang berang adota H2TE H2SE le H2S gas adi khap ta ni a boiling point rem dan khi a reason ve thung hi lower boiling point nei turani amero chu due to the presence of extensive hydrogen bonding in water it has higher boiling point saron tita hei hi adi khap ta ni water a khian hydrogen bonding a bi ka wang khanin a boiling point aron sang ta ni chawang chuan kan than tur chu both statement 1 and statement 2 are true hei hi kan chana turani ta ni apa hi khian adika dot le kal leng heta chang question number somruk le pahni na ni a arrange the following elements in increasing order of electronegativity hepo akol le maya chan chu aron pek khi kan shat lar periodic table la po kan shat lar third pay kha ron petani second period ni ron pe a ol maya nitrogen oxygen fluorine carbon le silicon te ron da a apoi mo ta ber chu periodic table thiam chian apoi mo ber ani khoya nge an ti kha chian angai boka chuanin kan han ziak chin anga carbon nitrogen oxygen fluorine oma khonge silicon carbon noya ta hian silicon kan neya kimite aron da tlar ta ni kimite panga khi chuan enge electronegativity kan ti chuan electronegativity chu an inkara an share pair of electrons an mani lama bonding alo ta khalai bonding lo oma an inkara an share pair of electrons an mani lama an hnu tai theina dan an pull theina dan kha electronegativity ni tani chuan electronegativity chu phezong in periodic table khan phezong in period zong khan a increase down the group khan a decrease ve thung chuan class apo kan soinguna hayara po hepo heichu kan zirna sign ka sia tunge electronegativity nei sang ber modern periodic table kan ti chuan fluorine mai ta ne he fluorine is the most electronegative elements kan soinguna fluorine hi number 1 a omenge turani sang ber don ni option hi an en le ta shimshimila fluorine san ber na option kan nei chu helai hi na khi 1 na le 4 na hi chu kan da bo thei phot kan risk don ani po in 2 na le 3 na ha kan risk thei ti na ni chu chuan adot le kan en lenga phezonga increase kan tia wang han chukzong in a decrease chukzonga decrease chuan tunge hniam berang silicon hi hniam le ber don ani electronegativity khati chuan in silicon hniam beronga fluorine asang beronga adot na silicon dota carbon na omanga adota sang le tur chu nitrogen adot le oxygen adot le fluorine chan khoye kan answer tur silicon carbon nitrogen oxygen fluorine lai hi kan chan na tur khani tani simple le amni tu NEET question chu pathian zara class kan explain ho nge ani he aron chuak simple phian arin ai takin kan zir food le ani Zawlbuk Zirna run no pang di chuan nuam kan ti le po kan be se ani class kan zirang ang te ron chuak ve a kan long le ani question number samruk le palina cherchinang the energy of an electrons in the ground state n equal to 1 for helium ion is minus x joule, then that for an electrons in n equal to state for Be 3 plus ion in joule is aron tia hi question kan en ang khian le option hi kan en wangwanga kan hu phurni na langa amai ro chu han chokila hote kha lo ni le sia kan hu phurang ai khan question hian min bum reu ani phela an en chin taila khoi tanga ron kalti chuan hei po hi structure of atom sa tang thoron kala ni structure of atom sa tang in question pati ngot me ron kala tuna kan cho zo tak chia pati kha classification of elements sa tang ron kala class 11 le khabu ron chuak thale ni chuan hei hi entropy ka tang ron kal kan ti chuan Bohr model of hydrogen atom khani tani Bohr model a tang ron kal khani ya energy of electrons kan chok chin don ani en bang tai la kan nei tur khi helium kan nei dona helium atomic number 2 ani helium ion plus ada wangin 2 atanga pakhat kan pai chuan 1 2 hydrogen chu puyan ta thange ngei don ani electrons pakhat ba kan nei don lo electrons pakhat chian nei beryllium aron da beryllium chu atomic number 4 ani electrons pali nei mero chu 3 plus aron da le ki pathoma lo suan beryllium pon pakhat thawa nei don chu an pani khiam electrons pakhat nei hydrogen thuk puyan chak don ani Bohr model of hydrogen atom atanga ron kalani kan ti to kha chuan kan chok chinang the energy of an electrons in the ground state n equal to 1 for helium ion is aronti helium ion ta na energy of electrons 1 minus x joule tuk aronti engkinge tuk thei kan en chin hot don ani helium ion formula kan apply tur kha energy of electrons hi kan shat lo ve thung chuan a boy thak ta ni for hydrogen atom electrons pakhat nei tan khan kan man tur chu minus 13.6 z square into n square ai kan thiam angai ni z square nuclear charge atomic number zat khazia turani n square n chu khi ron pem ta a helium ion sana kan n chuan minus 13.6 into z chuan exam nge tuk ta kang le exam nge nuclear charge helium chu atomic number 2 alo ni ta a chuan n ron pelo ka khonge n equal to 1 square minus 13.6 into 4 minus 13.6 into 4 lo chua ka hei hian atluk chu is minus x joule na ron tukati hei hi electron volt ten ron da the joule ten aron ni the bok unit sang sang kha nei ve theya convert ngai te pok khana ma ro chu question khan ki kat ngai har sat na tak ma ro chu all deuh si khan ita ni hei minus x joule na ron ti hei hian atluk chu minus x eng po a number hi ron chuak se minus x joule atluk an ta ne chuanin beryllium tan kan ti ve le anga En minus 13.6 z square by n square ve thung chu minus 13.6 into beryllium nuclear charge zat chu 4 square 4 into 14 ka ja kang chuanin exact nge n tan khan beryllium kha helai hi n equal to 2 ron ti a 2 atluk don ani 2 square chuan minus 13.6 into n ran ta ila khuinge kan cancel the minus 13.6 into 4 tho a chhuak ani chuan hei hian enge tluk ve theiang kan ti chuanin minus x tho kha tluk don ani hi a in ang reng don chuan enge kan answer to helai hi 2 minus x kha kan answer to rani ta ni structure of atom satanga ron kal kan hu phur deuh si ma se lo holam deuh si kha ni ta ni chuan adot le kan kal le anga da E naught value standard electrode potential ania for the Mn3 plus ion Mn2 plus ion couple is more positive than that of Cr3 plus Cr2 plus or Fe3 plus Fe2 plus due to the change of question ki mi kan en thianin cho vak kan tuma mero chu cho ngai hia lo khania manganese le chromium le iron manganese le chromium le iron kha electronic configuration kan hria chuanin all tu kha ni le loitani standard electrode potential d atanga ron chhuak ania d block atanga ron kal kha ni ta ni hei hi manganese kan enang nur le tlat mai manganese shim kha atomic number som hi le pangana nia intinge top don kan ti chin kha 4s2 3d5 helaya 3d5 anaya wang hian d ya khanin electron so malenga helai panga ne wang hianin half field cha nia chu wang chanin a stable mmani is more positive than that of chromium and or iron ati chan ki ni ta ni iron le chromium ti aya a positive chan kha helaya d5 half field anei liao wang hi shim hi ni ta ni chuan n thin ta ila mn3 plus le mn2 plus san kan ja thinang mn3 plus masa mn3 plus ape helai tanga electrons pathum kan loss chuanin helai mi loss masa dona adota hedana kalanga 3d4 mn exactan ngele dotlia khianin 2 plus ania mn2 plus san chuanin 3d exact nge niang pahni loss chuan 4s2 mi loss anga 3d5 ani chuan exact atang nge in change ta ngai toi taila mn3 plus question khia ti masa ka wangin mn3 plus to d4 atangin d4 to d5 hilai in change wang te mai khini kan answer to chu khainge le d4 to d5 configuration d4 to d5 configuration in change wang mai khini tani helaya chromium le copper aron pe ka wa chromium le iron aron pe ka wang khianin kan ngai har sa deuh mai ni na langani kan chang zau trap to question number som riat le pahni na among group 16 elements p block atanga ron kal thawani group 16 aron war le ani chin khan water te H2S gas te kan soi zo chi a ka group 16 thaw ani a tuna po 16 thaw tang ron chak le ni which one does not show minus 2 oxidation state minus 2 oxidation state tu nge so lo ron ti a in danin jak le ang oxygen masabera aduta sulfur selenium tellurium le polonium ten ni a question khen paliron pia sulfur hiron ti tel lova ichuan hemi te hi group number 16 an oma group number 16 na an oma enge an oxidation state so kan ti shim chuan oxygen te chu charge sa -2 kan pek sak zi a oxygen hianin an tumber chu an valence electron na pariat nei kan ti thin kha a valency oxygen hi 2 ani wangin -2 kha kan jak thin ta ni oxygen hianin paruk electron saneya valence electron pariatin nan pahni ma mo chuwang chuan double bond kan jak thin le -2 charge kan pe thin chuan heng ho zong zong hian a in ang vek don ai mero chu positive le negative form thang ta ni tuna kan soi kha negative oxidation state ani ta a positive a om le boka positive an so thei nual ani an ni ho khian chuan positive an so thei na khi chuklam down the group a khian a increase ani tia kan chuk khianin positive an so thei na increases down the group a chan chu heng ho hi inat per effect bang khan ni ta ni ns2 np 4 an lo nei ta a helaya pali an loss nu hian helaya pahni loss hi an phal to ngai lo chu inat per effect kan ti wang khani ta ni an hnuai lam ho hi positive oxidation state an so na sadona chunglam hian negative oxidation state an so na sadona ani chuanin an ngai to wang ta ilangin which one does not show minus oxidation state ron ti chuanin minus so lo tur ho jinga tel thei chu an hnuai lam khai thang mai don ani polonium hi thang don tina ni chu yo hi claim in question hian tu thu asam lo deu ka tia keima atang chuan a chan chu ne khabuchen khat a chuan atam zo ka chuanin hemi te group hian -2 so thei vek ani -2 an so thei vek chuan positive po an so thei chuan positive an so thei na hi noilam panga increase a negative an so thei na hi chunglam panga hianin a increase ve thong ani ma se question khian tu nge -2 so lo aron titlat boxia chuwang chuan -2 so lo tur ber positive so na sa ber zo kan than don chuan polonium hi kan thana ngai si ni kha omjia ni atin polonium shim hi radioactivity ania pollen atanga pollen ti minga atanga ron kalania this question a kaleng halang spin only magnetic moment is same for which of the following ions spin only magnetic moment kan zirtin kai po d block atanga ron kalania Ti3 plus Cr2 plus Mn2 plus iron le scandium te ron pe a chuanin kan ziak chinanga khoi nge spin only magnetic moment value in ang nei chu kan jong chhak don ani scandium a pe a titanium a pe a manganese chromium le iron te kan ziak chin don ani scandium ron pe a titanium chromium titanium a pe a ma ka sia na di thelo titanium chromium a pe a manganese a pe a iron a pe heng hau jong hi sia panga 1 2 3 4 5 scandium titanium chromium manganese le iron te ron pe a hi 3d1 4s2 3d2 4s2 3d5 4s1 3d5 4s1 3d6 4s2 hei mi kar zia hi chu kan bel to ni class a khan kan zir huna hei lai hi chu bel le tur kan ti ringot maya chuan scandium khian engzan ne los don tha scandium khian pathum ma los anga titanium in pathum ma los bukang adang in 2 an los son ani scandium khian pathum ma los chuanin engzan nge ne yang scandium khian pathum ma los chuanin 3d 0 ani don ani titanium hian pathum ma los chuan 3d 1 chau bang to dona chromium hian pahnih loss chuanin SME pakhat helai mi pakhat loss bukanga 3d4 manganese hian pahnih loss chuanin 4s2 kalau zia swal reu ni pahnih loss chuanin 3d5 iron hian pahnih loss bok chuan 3d6 unpaired electron omzat kan enangai ni ta hian unpaired electron omlo unpaired electron pakhat a oma ta hian unpaired electron hi how many unpaired electrons ta hian unpaired electron pali a oma ta hian unpaired electron panga manganese a om ve thunga iron a hian exactly unpaired electron somang di chang le zwal turin 1 2 3 4 5 6 how many unpaired electrons 1 2 3 4 unpaired electrons chromium le iron te khian unpaired electron pali ve an nei do na unpaired electron pali an nei chuanin spin only magnetic moment zonna hemi zonna root over n plus 2 bor magneton kha apply turani mase hemi apply kher lo hian shortcut khan kan zira a value kha an bai hatani unpaired electron pali ane chuanin a value tur khelaya pali substitute a hemi chok chok kher lo khan 4.9 kha an bai hatani 4.90 bor vel kha an nei don ani bor magneton tunge in ang nei tur chu chromium le iron chuan khonge chromium a om helai hi chromium a oma iron an hnuaiah hian a oma b le d hinan nei don nge kan chana tur b and d only number 2 itani Zau to don chepa pahni sia to a question number samria le parukna given below are certain cations using inorganic quantitative analysis arrange them in increasing group number from 0 to 6 ronti a b c d e ron pe hi rem tok turania maro chu helaya table thiam tan lovero chuan rem the ani lautani rem the ni lautani table thiam tan lo chuan table thiam tan ro chuan all sum to ka table mila rem top khenia kan en chin don ani aluminium khonge aluminium om helai hi aluminium oma aluminium hi group number 3 pechinang ta hian aluminium hi group number 3 a adot le a cu2 plus cu2 plus helai hi oma group number 2 a hi group number 2 a ba2 plus ba helai hi oma group number 5 a hi group number 5 a CO2 plus nghe le CO2 plus group number 4 a It's one Mg group number 6 a hi group number 6 a kemi indo ta rem khene mai tani 2 3 4 5 6 2 a tunge don b ma sabera b khonge 3 a palina ve thung chu d it's one pangana c e b a d c e b a d c e hi kan chana turani hemi table by heart mai khani tani table by heart kini a athara tanga ron chok khani tani syllabus se anon tidang lamna sa ko mina khan question kaldan tur te sha thiam har maya chuwang chuanin anlo inbox sai thiam te po kha har hle mai he po hi chang thelo te po kan nuk ve thawani chuan a top ber chuanin hi F block atanga ron kalani ve thunga the pair of lanthanoid ions which are diamagnetic is diamagnetic ron zota F block ani a F block general electronic configuration kan inzia tirna sa amero chu alo thiam chiang tan lo le F block ho an atomic number she lo tan chuan he hi all sum te si in question all te si in atomic number shat lo chuan chan thei mi alo ani chuwang chuan atomic number shat angai ni kan jak chinang cerium a oma jak pheina tor hi cerium atomic number somnga le pariadani a jak chin thor meang ginon shortcut ki kan mang don ani shortcut ki man lo chona boy thak wangin azia chunga re wangin ginon atomic number somnga le pali kha mang don ani ti chuan adot le a hi f d s hei hi 4f 5d le 6s te an omani cerium shim electronic configuration chu ngariat ka da do na ngali ka da to ngali nga ru nga sari nga ria tani ichuan question ina min peki ce 4 plus le ce 3 plus oma kan chin potang ce 3 plus kan tiang tuna pathum helai tanga pathum kalos tir chuan exam nge lo mang a sami los ma sabiranga do ta f ania pathuma los chuan ala bang tur chu 4f helai chin zel chau hi ja kang 4f a hianin pathuma los chuanin tan pakhata bang don ni chuan seriam tan 4 plus ala pe ka wangin pali los tir turania pali los chuan 4f a hianin 0 don ani engma electrons om don lo tichuan a dot le a kan ti le tur chu pm a khian kal leng pm promethium a kan kal lenga promethium atomic number he takhi atomic number hi kan thiam lo chuan chan ngai na om lo bur ani top mai ni bai hat tur kan tingun kha samruk le pakhat chuan jiak le chinanga ginon ngali f d s 4f 5d le 6s ten ni a samruk le pakhat ka fill dona ngali nga ruk nga sari nga ret nga kwa samruk ruk khat ta hian panga da ngai ni pm a 3 plus ati a pathum los tir tur pm 3 plus ka zia chuan exam nge ni ang ta hian pathuma los chuan 4f a bang za tur khi 4f 4 pathuma los chuan abang don ani dot lia sm kan jak le ang sm atomic number 62 ginon f d s 4f 5d 6s ngali nga ruk nga sari nga ret nga kwa samuk ruk khat ruk ni ta hianin paruk dangai ve thunga sm a 3 plus pathum los tir tur sm 3 plus ani chuanin 4f exam nge om theyang pathuma los chuan heta hian 5 5 om don ni exam nge tu tinge la bang cerium kan to promethium kan ti to a samarium kan ti to a iter europeum le gadoli diam la bang boka europeum EU kan jak liang atomic number samruk le pathumna ginon F D S 4F 6D 5D 6S rukthum ni chuan tan tru ka da lenga exam nge ta hian nga yang ruk pasari ngai ni ti chuanin EU exam nge los tir tur true plus pani los chuan helai mi los anga 4F exam nge om don pasari lot le ti le tur chu EU a khianin 2 plus le 3 plus a om ko phei EU 2 plus kan ti to a EU 3 plus kan ti leng EU 3 plus a chuan pathum kan lo sir chuan 4f a hian 6 om don tinan gadoli diam GD pathi chia om to a GD hi exceptional case kan ti kha ni a hi kan zero na sa maya F D S 4f 5d 6s ani a samruk le pali ni a kan ngali ka jak zo to ngali nga ruk nga sari nga riat nga kwa samong ruk adung hi ruk thum ruk li pariat fil tur ani helaya pariat da ai hian pasari ka da nga pakhatala banga tan ka kalti ro ani half fil ani theina turin pek tur ani chromium le copper exceptional case ang chia khan ni chuan GD a hian exam nge los tir tur GD 3 plus GD 3 plus pathuma lo swanin helai SME lo sanga adota F a kal don ani chuwang chuan 4F6 tungela bang YB chia bang to ytterbium YB atomic number 70 ginon F D S 4F 5D le 6S samsari don chuanin ngali nga ruk nga sari nga ren nga kwa samuruk ruk adu ni ruk thum ruk li runga ruk sari ruk da dukwa samsari 14 YB 2 plus ani a pahnia los le ang YB 2 plus a chuan tingjan nge la bang hi lo sanga 4F 14 an so ta a ni chuan tuna kan ti tur chu n mil chia ngai to ni tu tinge diamagnetic aron ti a unpaired electron nei lo atina ni tu tinge unpaired electron nei tik chin photang heta hian unpaired electron om don kan thlang thei lo promethium a heta hian unpaired electron hei om chiang sa kan thlang thei lo SM a unpaired electron om kan thlang thei lo samarium a ta hian European ma 2 plus a 4f a half fill chi don hepo unpaired electron a don ta pon unpaired electron a don ngado lithium ma po tan 6 a don ani chuan tu tenge unpaired electron nei lo enta ila he 4f 14 a in pair vek don yb le ce 4 plus he diamagnetic lak turani chuwang chuan kan chana tur chu ce 4 plus le yb 2 na hi kan chana turani ta ni ce 4 plus and yb 2 plus khati zong kha ka chana changa karon analyze ni ya dang hi teacher dang ten an ron chun zom do ya ni
chemistry organic part kan analyze ve to thunganga tuna chan kaloma in organic big a hianin prediction class a kan soi chinang chi tele mimala min lo zo kan soi chinang khanin question a kha aron ta flu tuk lawa amaro chu tungkuma hianin class a po ka soi thoi chin kha chu in zireng renga kha thiam chang wala question ron standard ang ti khani ta ma se question hi ron standard vak chang lawa bokina tungkum chu syllabus an reduce awang khanin tlema ron high five ye de kha kan ringa amaro chu kumdang ang thau khanin a thende pe chang kumdang ain all inti karinga zirna satan chuan organic a big takin kumdang song ain hetia han exceptional case kan tiang chi te po a om vak lawa nya chuanin reaction thui deu dewa han zir ang chi te kha om chang lo ta thiam chuan thiam to pang chi kha atam ve ta ni chuanin question a kha ka soi tawng kanin hemi chapter a chuanin chu tiangcha chu a chhuak ang ti kha soi thei mia lova ka ti kha organic a chuan chapter pakhat pani pathum te kha question pakhat a khana ron tel te thina chuwang chuanin kan thil zir reng reng a kha in thiam chana class a in thil zir a kha in sha chen kha chuanin question tu na ron kal reng reng a hi chan tiam lo tur kha pakhat mom lo ni class a kan zir vek khani ta chuanin tu na kan video lo en kan institution a kal kherlo te ponin lo en thei thawa chutiang te tampo chuanin in sha tur chu in institution a in zira kha atok lo tu kan ni tun question bi ga hi chuanin a chang chu ta achunga mi lutuk details lutuk ang chi kha engman ron zot lawa question chen khate pe hi chu he chu ni ta ta na ron chhuak tan chuanin a ol deu lo mo ti 90 malam pang ron chhuak tai pang chi te kha ron tel te dei chin ta kami ni wang hang question prediction hi tung kum chu a theni a haranga a theni a olang hi chu har deu ron chhuak tiang hi sha thiami a har thine me ma chu wang chuanin ti the chu tu tampo in zir reng reng a kha chian kha poi moni me in class a in zira kha mo kha chiang ola chuanin question hi tam zok in chang ka ti chin kha kan student a big takin ka sei china kan no jing ho te class a attentive ho tan chuanin in class note hi in thiam vek chuanin 70% of your question a kha an chang the vek ang ka ti kha ma se 30% a kha chu nangmani zir ve lawa kha ne hat ka ti china chu chu ron lang don ta cha ta class a kan zira kha chanila hi class a kanin pe chang im china oxidizing agent te reducing agent te an exceptional case thlengin ka pe chin chewa kanin pe china khatyang ho kha aron chhuak ta cha ta ni tu na hianin kanenang hi kema portion organic be karon chhuak ma severely identify the correct reagents that would bring about the following transformation ania equation hi in en potang chu ta chuan question a hian nge thleng le ti kha in en ron ni chumo hi engi alkene ani tro hi alkene ani chuanin hi enge hi aldehyde ani chuan enge thlengang hi question a chuan alkene atang khan aldehyde kan siam reaction hi an enula ne reaction a kan reagent te hi chuta chuanin number 1 a hianin hi hydrolysis ania water kan telanga chuta chuanin pcc mo hi voi khat in en chuan in tik don nia o voi khat in ena a hi chu ani nga lang tia in tik pop chuanin one hi in tikang ma se engting e class a ko searching kha in thiam chian to in understand to reng chu in first thought man lo to ke teaching ka in second thought zen in mangang first thought a chuan ti swala all chuan set lo tur ve khat first to reng kha ka ti kha cross checking nei zel tur tuna po hian number 1 a chuan in hi enge hydrolyze om ja chu hydration ti na ni alkene a hian i hydrate anga I hydrate zo a pcc chu enge pcc chu oxidizing agent pyridinium chlorochromate ania chu mi mang chuan I oxidize zona aldehyde a chuak don chang ma se khata khanin poimo chu hemi hi ronti hi achuak nge tur ti ni ta chuwang chuan engtin nge kan tiang kan ti chuan pakhatna chuanin hi cyclohexane ani a CH2 CH CH2 ani hi alkene ani a chu I hydrate don water tel don water telanga hi alaron chuak don lo ani mo hei laron chuak don lo hydration a chuanin chihni kan nei kan ti thin kha enting kan ti alkene a chuan addition reaction an kal tlang thina pakhana chuan HX kan tel thim panhina chuanin water kan tel thin HX le water kan tel khan rule panhi kan nei a chu chu Markovnikovs le anti Markovnikovs ani thina Markovnikovs ani chuanin peroxide tel lo ten kan ti thina ni chuanin anti Markovnikovs ani chuan peroxide tel thin ta intina H2O2 kan tiang chi te benzol peroxide kan tiang chi te kha ka tek ang chi te ka atel te thin ta chu tiang chu chihni in nei chu chu film kur em manga ya chan chu reagent a hian specific reagent in man ngai to hian ron ti thlapa chu ta chuanin hela ya hianin water tel dan chihni kan nei ni chu pakhatna chuanin Markovnikovs in mang photang Markovnikovs a chuanin hela ya OH tel tur ni a ta hian CH3 in telang mo chuan enge kan nei le chu he ta hian tel ve thung tur ani anti Markovnikovs a chuan chu ta chuan CH2 ta hian CH2 OH hei inang talaw ani chu hei hi secondary alcohol ani a hei hi primary alcohol ani chu lai taka chu adang lam ta a hei hi in man chuan hei in ti chhuak anga chuanin hela ya hianin number peroxide om na mo peroxide om na chu hei hi ni ta ni eta hian peroxide in man chuan hei hi in ti chhuak ang chu tiang tho chuan ta po peroxide in man chuan hei hi in ti chhuak don ani chu chuwang chuan peroxide om le om lo peroxide om chuanin hei hi in ti chhuak zelang hei hi chiak zelang o H2O2 amin hei chu H2O2 om lovin poimo chu kan na sei thina oxidation of alcohol a khan primary alcohol oxidized to aldehyde secondary alcohol oxidized to ketone kan ti ta ni cham final oxidation product kan ti thina kha carboxylic acid zelani kan ti thin kha chu ta chuanin carboxylic acid final product aron jang me lo aldehyde ani chuwang chuanin aldehyde siam tur chuan primary alcohol i du ani chuan peroxide omna I thana ngai ti na nia chuwang chuanin 1 le 2 I thang thei lo shim shim ti na ni ani chuanin 3 le 4 I thangang ani le enge oxidizing agent hypo oxidizing agent OA thonia hypo oxidizing agent thonia ani le ngen dang lamna KMnO4 kan ti reng reng chu strong oxidizing agent ani wangin final oxidation product hi carboxylic acid ani thin amairo chu PCC kan ti class ka pek thin cheu kha pyridinium chlorochromate kan tiang chi te Jones reagent Collins reagent kan tiang chi te chu they are exceptional oxidizing agent ani awangin an final product kha danglam ta thina ni kan ti kha PCC kan ti te po an final product tur chu carboxylic acid ani ngai lova aldehyde a top zelani kan ti thin kha chuwang chuanin helaya hianin PCC in man chuan helai mi in product a hi in siam chhuak don ti na ni chuwang chuanin peroxide omna le PCC omna kha in thlang don ti na nia ani chuanin number 3 a hi in option ti kan ni don ti na ni reason thlang tur chuan in thiam ta manga ya reason kha nile BH3 hian har satna anem BH3 chu reducing agent an ni o peroxide alu ma khanin BH3 an lo thina ni ma se kan T4 thina chu BH3 ron lo tira OH adwa vati le kha mechanism a thui thina kan tia chuang chuan BH3 chu ani na ang kan da ve to pula kan ti thina ka and THF te po mo ani na angin da to ni but ma sengin H2O chu om chuanin khesa nei to Markovnikovs emo anti Markovnikovs in thlang thei to ti na ni khata cha kam nanglam na oma kan sha tiam ang chumo details in class a kan soi china 52 the compound that will undergo SN1 reaction with the fastest rate hi assignment a han som li don kan in pe SN1 SN2 hi kasha swalo chuan chuta chuanin SN1 SN2 reactivity order zong song tin en kan soya chuta chuanin in no ta te po kan in pe thalu tuka chuta chuan SN1 te SN2 te engi an difference ang chi SN1 a chuan two step mechanism ani a SN2 a chuanin one step mechanism ani a tiang chi te reactivity order te stereochemical aspects kan tiang chi te kha kan soi facta chuta chuan SN1 reaction kan ti chuanin enge thleng two step mechanism ani anga poimo lut tu chu carbocation intermediates in siamani carbocation intermediates in siam chuan enge kan reactivity order ni ngal tur kan reactivity order tu chu tertiary secondary primary ani ngal don te na ni ani chuanin tuna hen enge kan ne hei alkyl halides an ni hei hi alkyl halides hei hi haloarenes an ni ta haloarenes an ni avai hianin option number 1 3 le 4 te hi alkyl halides an ni option number 2 hi haloarenes an ni ta ni chu ta chuanin thiam lo chuan risk kha ulta ni chu hundreds me ya diktur angalang ma se dik chuang si lo negative marking pet thei tu zeu kha umta ni chutianga chuan in han en me anga na option number 2 te hi in thiam vak lo le shapol tan chan in tik popang ma sengin negative in mudon mena son mo engwangi kan ti chuanin chan chu haloarenes kan ti reng chu haloalkanes ai nucleophilic substitution reaction an niam falu to kon tia class apo pathum chau kan zira CuCN te tro chan NaOH te NH3 te chau kha kan zir ta unreactive lo ni amai ro chu alkyl halide chu engzangi assignment te pokan in pe ka kanin zir tir kha som pasari chuang kanin pe ni chu ari esen pokha tam me ma chu wang chan helaya po 1 3 le 4 ate po hianin tu hi chu cut off magro adik don lo mo chuanin 1 3 le 4 a hianin in enang chu ta chon poimo chu SN1 reaction a chuanin reactive intermediates kan ti akha carbocation ni dona khoyangi carbocation in siama Br united na or X united na carbon a khan ani chuanin hey helai zel hi en mero thia karon circle zel hi mo hi kan X kan ti chu ni ta chu X united na carbon a zel chuan positive charge carbocation kha in siam don chuan engtingi kan ti stability order akha carbocation stability order akha and reactivity order ani haldung kan ti chuan ani chuan tuna hianin tunge tertiary secondary primary tin kan assign theya hei hi enge nyang hei hi he carbon hi kan ena tro he R group pakhat om he carbon a hianin R group pahnian om R group chhar dan te thleng class a kan soi chan tu homo he secondary ni a kan tia helaya hianin CH2 om dona he primary kan tia tro ta hianin secondary ni ang kan ti primary kan kat photang secondary veve kan ena secondary veve so en teu pakhazo ke hi chu enola benzyl carbocation ania poimo chu so tertiary secondary primary order so in enturania amaro chu ayala poimo oma chu resonance structure ni tani kan carbocation or carbonyl te free radical te resonating structure an nei thei chuani they have extra stability inductive te hyperconjugation te ka determining factor ani ve thawa amero chu resonating structure nei the chuanin heta unstability a kha sang fal big ta chuwang chuan ta hin en tawla hei benzyl carbocation kan ti ang kha ni ta chuwang chuan resonating structure ka ti hian ron kal thei ni chumo ti hian chuan ta hin positive ron omanga chuwang chuan in stability akhan secondary thewa po helai option number 1 akha stable awangin stability of carbocation means more reactive ti na nya chuwang chuan in option 2 chu 1 ani ti na ni all to pe chumo har omya lo tungkum kema part pe ka hian nei pe chu all to ka next a hianin ethane oma ethene oma carbon molecule C2 oma ethane ne san zia gang ethane oma ethene oma chuanin C2 oma ethane MOT mangte pona ti themo MOT inzir thena kha inorganic kha te poka man thei do ethane kan ti hi ming common name pakata ne chu acetylene kan ti ta acetylene pon ti theya ethane pon ti theya du dan dan khan ethane kan ti chu CH3 triple bond ani pi bond le sigma bond cha dang ka shil chin che watero CC in question kha in n le chuanin so number and types of bonds between two carbon atoms te ni ta carbon pani in ka ra khan eng bond sting e kan nei ti khan be chuta chuanin carbon te pania chuanin triple bond a chuan engtin nge kan ti 2 is pi and 1 is sigma kan tia turo ethene a chuanin hei kan nei a chuta chuanin 1 is pi kan tia 1 is sigma kan ti boka chuan ethene a chuanin engtin nge kan ti CH3 kan tia ni chuanin 1 sigma chawam ta ni hei kan nei dan tur chu ni ta chuan C2 hi C2 hi ti hian zia the ni chumo hei ti hian ani na chana kha MOT a inzir ta structure ka zia sak lok chewanga or structure ziak lovin electronic configuration MOT molecular electronic configuration kha ziak lokang I C2 chu isha dangin C2 chu 12 ania 6 plus 6 mo 12 ani ani chuan sigma 1s2 sigma 1 star 2 nyanga chuan 2 sigma 2s2 sigma star 2s2 nyanga pi 2px equals pi 2py nyanga chani sigma 2pz in kamching kani a som pani kan rem dona pani pali poruk pariat som pani kan rem tani so enge thleng kan ti chuanin pz orbital a hmanga pi man siam nan tro chuanin py orbital a hmang boka hai px le py orbital siam nan kana hmang ve ve ta chuwang chuanin kam pi bon nei tur chu 2 pi bon ani ti na ni chu chuanin 2 sigma bon mo ani chuan ta hianin enge kan na yang 2 sigma plus 2 pi bon chu kan rem don ani mo lo chin chia ro o I the na kha mi thlau lo ol me he tyang hi chu chuanin he tyang hawa hianin hun man he lutuk lo tur ani a then te ga in zo man lawa iten a chuan enge kan nei iten a chuanin 1 sigma bonds kan nei atro kan eng tyang kan thai de nge o tian iten a chuanin 1 sigma bonds kan nei a itin a chuan enge kan nei 1 sigma bonds le 1 pi bond kan nei atro sorry 1 sigma bond le 1 pi bond kan nei a hi ni don ti na nia ani chuanin enge kan nei le chu carbon molecule C2 ni ta tro C2 a hianin 2 sigma bond le 2 pi bond ni a chu tyang chuan ron in siak lawa a pi bond chau ron in siak ani hi mo chuanin ithaina chuanin 1 sigma bond le 2 pi bond ko sei to tro chawang chan he ta nianga ani chuan A le 3 na nga B le 4 na nga C le 2 mo D le 1 ani chu enge in answer to ni ta ang kaninang A le 3 ni chuan A le 3 om na hei le hei om atro chuan B 4 adik ve ve boka C kan en tuang C kha 2 pi bon ni a 2 ania C 2 om na konge hei zo ke ni mo 4 kha dik na tur ani ti na ni chu question chan dan te po kanin shil chang to thina chuang kan bel tur angai mo the most stable carbocation among the following ti ni ta ai tungkuma hianin carbocation reactive intermediate atang hianin pahni achua kan ti thayang achan chu na carbocation direct equation ron chwaka chuan indirect in SN1 ron chwak boka ani chuanin GOC in ti chin general organic chemistry in ti atang khan equation pahni akha aron chwak kan ti theidon ni chu amai ro chu a then te tan chuanin GOC in 0 pon in thiam thawang achan chu SN1 ang chi te ammonia lo pon dehydration of alcohol ang chi te in thiam kha chuanin he po hi aron tel vek thawa mo chuwang chuan GOC atanga yan aron chwaka GOC is lo chuan I thiam thon lo ti na ni lo ania alcohol part te chuanin nucleophilic substitution reaction of alkyl halides ang chi te khai thiam chuan hei chang thei tho don the most stable carbocation among the following tia khanin kan ti thina tan kan jak popom mengo hei secondary ni a hei tertiary ni a kan tia taro chani secondary ni a hei primary ni chang mai tu tertiary he elai mi ran don ti na ni chu for example internan tertiary a hianin hei ron ta ni amai ro chu helai a hianin khoi ber option tanga 2 3 or 4 a hianin resonating structure theya khalo ta se ani chuani tertiary ti ipon it depends on the molecules mo a molecules azir khani resonating structure thei chuani tertiary I tipon secondary te stable hon ron nei thawang internan secondary a tertiary carbocation te chuanin a resonating structure nei an lo nei lo tam ase secondary carbocation khanin a resonating structure lo nei thei chuan extra stability kha anei dong kan ti kha chuwang chuanin helai tertiary stability ka khom de anga most stable khana thlan themo chuwang chuanin eta kan carbocation mo carbonyl kan ti te free radical kan ti te a kha chuanin an factors akha buk thia man ngai thin mo amaro chu introduction ka soyang khan engma exceptional lo tung question a hian kumdanga chuanin ve thina a hei chu he tiang deuh tur hi ni dia hanin yal babab na tur kha ve thina maro chu tungkoma chuanin in thiamang ang kha changwala dik zelang in engma han ru te boy tu turang kha anom lo mo chuanin hei kan en lenga reagent thoni a tungkuma hianin reagent akha alo te pe chu kan student big takin atira khanin in la sha in karinga chartin jak ula ka ti chinka chart paper in kalaitir jo chu ta chuan oxidizing agent reducing agent te nucleophilic reagent te electrophilic reagent zong zong te jak ula bai han ru ka ti chinka chu chu apoi mo lu tu ka ni tungkuma phei chuan kha patni lai ron chwa ka ni chu ani na ta ka chuan reaction atangin a ron chhuak in ti theianga reagent atangin a ron chhuak in ti thei bawma che reagent le reaction ti chu thil kal kop tet kan ne wangin reaction thiam tur chuan reagent in thiam anga ya chu tiang thiam tur chuan in sir pe be khangai mo tu na nga te po hianin enula reaction ron da chu reagent a kha siaman ngai da zir tan chuanin a har lo dan chu har lo takani tungkuma mi ma se zir lo tan chuan oya har in ti thawang amai ro chu tlema han zir ve deuh tan kha chuanin thil har pakhat ma om don lawa e te po hi enula enge hi alkin an ni a ate de ule ka kan jak len de nge alkin ani a hi enge hi ketone ani enge omzia ta hian alkene hi compare ka tro alkene hi compare ka chu ta chang ketone mo aldehyde ta kan siam jin chen chu tiang reaction chu enge ozonolysis ani ozonolysis chu enge O3 in the presence of ZnH2O kan ti khan ya chuwang chuan in A le 4 in kom ngal ti na ni chu ka tiang reaction ang chi te kha nei pe chu ama ringa po hi in entropy in a reaction product tura kha chiang hala cham bi hi en le taula bi a hianin hi benzene ania o hei benzene ania hi benzophenone kan tiang chi khani ta ni ani chuanin reagent hi en teu enge thling kan ti chuanin hei one kan ti helaya bi le one hi a in ko pang achan chu helaya a reaction hi ta hin kan ja ka nge hei benzene ania Friedel-Crafts acylation kan ti benzoylation kan ti khani ta mo ta hianin benzene ani a ta hianin benzoyl chloride an ron hmanga Cl an ron hmanga chuanin anhydrous aluminium chloride an ron hmanga hi Friedel-Crafts acylation mo FCA kan ti khani ta ni chuta chuanin kan nei tura chu osam theyang berin kan in zir tir thin dana chuan hi impre kanga katia chuan ta hian positive amanga chu positive chu helai hi chuan direct ani awangi I du du nei lu tirang apoi lo re ring kha chu mo du du na lu tir to pakha hi ni mei hi benzophenone kan ti khani ta chu chu ron chhuak don ti na ni chu ani chuanin b le 1 so ain ko pang si le d hi a confusing ta ni zir ve tho oxidation reaction zir ve tho ma ro chu eta vazir chiang vak lo tan chuani in confused na in boina tur ni ta chuwang chuanin ta po hianin hei confusing dewin option an ron da ta chia ta ni chulai chu in boina tu le na si enola hi alcohol ani eng alcohol nge tin enang eng alcohol nge hi secondary alcohol ani secondary alcohol chu engangi kan ti secondary alcohol chu ta hianin ketone in oxidation kan ti forward ro chuwang chuan ta hian oxidizing agent o mangai mo chuanin hei enula hi enge hi ethyl benzene kan ti khani ethyl benzene chu engangi in oxidize hei carboxylate o carboxylic acid ti na acid ta anin oxidize ti na ni chu in short tur chu acid in oxidize to reng chuanin strong oxidizing agent kan mang thin strong oxidizing agent kan mang thin hei labang hi number 2 le number 3 ni ta ni chu ta chan hei po hi oxidizing agent ani a hei po oxidizing agent thawan ni amaro chu khoya hian ni kan belang ti kha in boy do ni chu C secondary alcohol kan ti hi CrO3 a in da ang CrO3 hi secondary alcohol oxidize nan in da ang ti tiang engwang nge kan ti chuan a chan chu KMnO4 ai nan chak lo zo ka heta va reduce va oxidize so ra heta oxidizing agent vatlang tur kha chuan acid avatlang tur ka chuan strong kan mang thin mo kalai kha kan sha tanga ya chuanin mei ba ka in sha tur chu an compound na zir hian in agent hi adang lam thin ani entirnan soi to mei la benzene te po hi kan oxidize zona kan changa ether cha kha ether reaction a kan sha chu chromic chloride de kan mang ani khamo chromic chloride de kan mang อันมันนี่ก็ไฮโดรคาร์บอนจันนี่เท่าเบนซินนั่นนี่เท่าอาไม่รู้จะเองวางนี่กันมันน่ะชันอาจารย์จูคา reactant เลยเฮลายกัน reactant จะค่ะ they are suitable for reaction an reaction กัลจังนั่นตัวราคานี่อันนี้ก็ big ชิ้นที่นั่นนี่จูบางตัวนี่ reactant กันทันแรงแรงเฮียนี่อันนั้น reactants มีขั้นกันทั้งชิ้นนี่โมดูกันมันเตะแล้วว่าไม่รู้จู oxidizing agent ตาจุน common oxidizing agent กันเนี่ย caminophore เตะตัวนี้ potassium chromate dichromate kan tiang chi te heteng he chu engpo oxidize thaya amai ro chu ka oxidizing agent mo reducing agent ta khan specific ka khanum ta enge mo light up entenan diol kan ti ta diisobutyl aluminum hydride kan tiang chi te heteng ho te chuanin indu du kha ava oxidize thei chuang lawa ava reduce thei chuang lo ta ka tiang chi oxidize reducing agent ni taก็ยังspecific ก็ขนมตัดเชียร์ชันเทียมค่ะโมอันง่ายลุตุกะแต่พอเห็นนี่ CRO ชีแต่อินดาจวนดิกโดนแล้วว่าจวงจวนนี่สีเล่CRO ชีนก็ปังอ่ะจวนนี่อีไทล์เบนซินไฮโดรคาร์บอนแรงจูpotassium permanganate กันติดชินไทยชินังกันไทยตัวตัวจวนนี่ทรงชินังจูเองมอจู4เนี่ยนั่นเนี่ยให้เลี้ยให้กันติดไทยจวงจวนนี่1เล่3กันไทยตัว B จูเองเนี่ยนะ B กันที่จู1เนี่ยนั่นเนี่ย B1 เบเวรันเนี่ยจวน C จู C ฮีจูยัน3รันที่ได้แต่ได้ตานี่โอ้ให้ไล่ใจฮีนี่ confusing ตัวจูมั้งจูวางจวน option อ่ะจูนี่จูอินที่จวน minus 1 in มั่ง4อินที่จวน plus 4มั้งก็ไล่ค่ะที่ส่วนเกี่ยวจวนอินทร์ดอร์ที่ยาอินชาวเทบุกปกติส่วนป่วยรู้ตัวกันอยู่จุ่มบ่ปกติส่วนเราวางกันอีดูใน institution ให้รู้เราพาไทยจะวางจวนนี้อุโลกังไงและ 73 next question เกี่ยวกับปาร์ดาที่ยังa compound with a molecular formula of C6H14 has two tertiary carbon its IUPAC name is เอ้ยอย่างนี้เราตัวเอ้ยอย่างเสียดังค่ะกันเสียชินค่ะจะวางจวนเสียปุ๊บนะ tertiary carbon ปนิในอันเดียจะวางจวน tertiary carbon ปนิในใครเอ็นโดนเอ็นวังอุลาจังซาจะให้เฮียนินเอ็น tertiary มาในโดนหรอใช่ไหมที่รอจวนนี้ให้จวนนี้ปากกัดเจ้าในโดนจากเช่นนั้นปากกัดเจ้าในดันตัวจะเป็นเต็งกันที่จวน carbon ปังอาข้าเสียปุ๊บละปังอาเนี่ยงาจูเมทัลนี่จวนนี้ดูเบอร์น่าเสียชีดังให้เจ้าเฮียนินนั่นเองอ่ะบางส่วนจวนนี้ให้ secondary ให้ primary มั้งให้ primary อารมณ์นี้เลยอ่ะจูวังจวนนี้ในตัวจูปากกัดเจ้านี่ only one tertiary carbon จูวังจวนนี้correct แล้วตัวอันเดียวกันนี่จวน number 2กันเนี่ยนัง2 dimethyl butane นี่butane นี่จวน carbon ปลี option number 1กันจากoption number 1อ่ะจวน2 dimethyl นี่จวนตาเฮียนจากไม่ลังอินที่เฮียนอันว่าเฮียน isomers กันนี่ที่ชาตัวนี่จำsecondary เนี่ยให้ primary เนี่ยให้ primary เนี่ยให้ quaternary เนี่ยอันนี้จวนนี้ tertiary น้องเนี่ยเราตีน่ะเนี่ยอดีกเราตีน่ะอันนี้จวน number 4เองนะ number 4ให้ butane 4อันนี้2 dimethyl นี่จวนตาเฮียนจากไม่อุลาให้ tertiary carbon ปัญญาเราน้องตานี่หมดตาเฮียนจวนนี้ให้มีแต่ให้ in option ดิอันนี้ตรงตีน่ะนี่ direct and run ti chwa lo sham hian tum veng alanga nta heute ya ajan chu C6H4 he mi te hi isomers an ni ta ka chuan isomers an ni a hexane an ni a chu ta chuan in C6H4 chuan in enga chain isomers eng sang en eng ti te kha kan zir thina chuan in chain isomers lo nei ta chi an isomers ming te po kha ziak chuak thren ro kan ti thin kan ta chu ta chuan in hei mi te po hi isomers re kan nia amara chu IUPAC an ron tel ta ni isomers le IUPAC khan ron da kop ti ne IUPAC a po he ollu tu ka ming ron da sa ve ka structure in zia thiam anga ya chu structure chu in zia thiam chuan tertiary le secondary primary quaternary chha thiam khan ni me kha chu ar lo mo primary te secondary tertiary ti de ka chu ne tang hi inu por chin ka nia ma se statement aron ti chwajing a chona all vel to ka hi chu physical properties kanya physical properties of hydrocarbons kan ti kani tani n pentane kan ya isopentane kan ya neopentane kan nei ta pakana chwani statement hi char potang statement number 1 the boiling points of three isomeric pentanes follows the order tia n pentane greater than isopentane greater than neopentane statement number 1 mo Statement number 2, when branching increases the molecular tends a shape of sphere. This results in small surface area for contact, due to which the intermolecular forces between the spherical molecules are weak, thereby lowering the boiling point. Statement 1 le 2 hi option hi enta ula. Option statement 1 is correct, statement 2 is correct, both are incorrect. Yang chi kanaron da top tani. And then an assertion le reason angin aron dalo phaichan all le swal achan chu atikle diklo thar to pani assertion le reason aka chuan in assertion kha in reason in ashil fiaim ti lai kha khalai kha in ti swal lai ani chin ta ni wasi tu na chuan ani mia lova statement 1 le 2 kha dikem ti to pani en chinang en penten chu hei hi ani hei en penten ani chuan isopentane kan ti chuan hei isopentane ani neopentane chu 1 2 3 4 5 hei neopentane ani ta pathum kha kan nei ta ni chuta chuanin isha tu chu n pentane te isopentane te neopentane te kan nei ta a reason shanga kha theya boiling point cha khan reason only bearer ti chuak ta chuta chuanin in textbook le no bo in sia forward chin na chu ending kan ti boiling points kan ti reng a chu a chan pakhatom theya sana chana chu pakhata chu unincar force chakle chaklo wanga ni theita ni entina water kan ti te le alcohol kan ti te compare taula water te alcohol te atunge boiling point asang enga tangin nge intiang intermolecular forces chuta chuanin CH3 CH2OH ania CH3 CH2 CH3 o carbon inang mangang hemite ni ta se engti nge intiang aning kara CH3 hei ethane ania hei ethanol mo CH3 le CH3 in kara in force nge CH3 CH2OH in kara in force nge helaya force makha achakle chaklo kha apoi mo tani chu achak phat chuan boiling point sanga chaklo ni chuan boiling point an hiam thamayang ani chuan in chumi chakle chak lo chu tu ting ye shilta pakhana chuan in shil tu tur chu anin hlatem ti te popoi mo nga tiro hei kanin hla chuan interaction atem tiang deuh khan in la chuan interaction atem anga ani nei chuan interaction alo na sa anga chu tianga in nei interaction na sa tu chuan enge poimo surface area ni tani surface area kha poimo te ta hei kut te po henula sir jong ti chuan surface area tlema hei force kha atle manga energy in siam chak te mang ma se kut phale kut patia kan ti chuan enge thleng kan ti chuan surface area tama wangin aron lum vat maya ka tiang deuh khanin a surface area hi tam reng chuan energy an pe chuak nem chinda chu an energy chu forces kan ti ta chu forces chu achak dong ti na ni surface area tam chuan chu pakhat ani ta ni chuan pakhat le chu unstructure apoi mo le ta ni chu unstructure in rem dana kha poi mo le ta chulai in rem dana tang chuanin an boiling points te kha alo shin le ta ni chu taka chu helaya hianin enta ola hemite engkara hian eng force nge kan nei chu induced dipole interaction kan tiang chi forces akha inshanga tro forces a pu achak lo pe rakha ni ta ni chu hydrocarbon cha chu nam present thin ta am boiling point an hiam amaro chu anyam cheu wa khanin tungi sang ber ti kha kan en angai ta chu ta chuanin ai hi isomers pe kan ni a chuanin kan hmu thina chu in in chena chu isomeric hydrocarbon cha or isomeric compound na reng chuani branching a tampo le an surface area kan tia kha mo an surface area kan tia kha alo zimanga kan ti thina ni engatan interaction atan alo zimanga na chuta chuanin alo zim chuan forces an inkara forces ka alo nyamanga becomes weaker chuta chuanin alo nyamani chuanin an inkar force kha aron chaklo nga langa tinani chu chuanin an boiling points an hiam don tinani enula ta hianin hei chu straight ania turo chu wangchang surface area kha nei zau ta ani chu hi lai zong kha nei ta hei okay hei lai zong area kha lai zong hi ron nei don tinania wo he lai pang zong nei khan loko hey so anwai zong nen ma se helai ve chu branch akha lo ta chu wang chuan in helai surface area kha a chung oma anwai akha nin midang ne na va in interact tur khanin he surface area kha ne zau tok lo ta pe chuan a jim te em ta chu wang chuan in helai in statement a khanin n pentane isopentane neopentane kan ti te a hianin surface area kha decrease tha ka wangin am boiling point kha aron an boiling point kha chakla wanga chan chu interaction force kha chakla wan ti ta chu da chuan statement chu khan ron shil fia te cha ta ni when branching increases branching atam chuan surface area tlemanga surface area tlem chuan in interaction force molecular force kan ti kha ron chakla ngalanga chan am boiling point ron hnia manga ti ta chu chu ron dik ta ve ta ni chuan in option te po hi lo thak se intina statement 1 is correct atia statement 1 correct ka statement 2 po correct ka chuan in statement 2 is the correct explanation for statement 1 po ron ti se dik thawang achan chu surface area chung chang ani hei mo chuanin and option carbon all time van nei ni me which one of the following alcohols reacts instantaneously with glucose reaction hei crash course a po ka soya now course pa nga ya po kan chei ta kum tin te sa hi an kan ngai lo amine chani emo alcohol ani emo aldehyde ketone ani emo khoi om bera tang hian question he ron chang nge chin kum kan ti fu de kum phei chuani pahni te ron cha ka chuta chuanin in zero ber ani tu mani chuanin van doi ni me amaro chu in test reng a hi chu kum danga in exam lezel tur atan po zir zelula tha mo test hi chu chan chu an kan ngai vak lawa Lucas test ron chuak ta ni ai alcohol test ania Lucas test on Tom Victor Myers test ti pokhom don ta Lucas test kan ti chuanin kan sianga anhydrous zinc chloride le HX HCl kan man khani ta ni chu Lucas reagent tu nge Lucas reagent chu HCl kan manga ti ro HCl plus anhydrous zinc chloride kan mang thin ta ni ta chon alcohol ne na nin react dona an siam tur chu engi alkal halai siang lu tu khei chu test hi thiam me lo po ni ulamo ne emi tun tum question ron chana chu test hi zir me lo po ni ula he reaction hi test ne ka zir lawa ka chang lo mo yang in lo ti pal chana poilu tu ka class in attention chuan engting ka soi interaction zong hi test ani ngal vek zel ka ti ka ta po hian alcohol o matiro alcohol o ma chu alcohol chu HCl ne ni chuan enge thleng ta hianin RCl aniang ani chuan enge reactivity order ka pek cheu kha tertiary nia secondary nia primary ni ani chuanin in tertiary so a reactive ber don ti na nia ani chuan in tertiary alcohol chu khongi enula chan chu azo chu reactivity order nia Lucas reagent in interact chak ber ani chuan tertiary alcohol chu he changlu to hi tiro hi primary nia nga hi secondary mo hi primary aroni don ti na ni chu Lucas reagent ni le ngoro he kan sei lok ta hianin azir te tan chuanin question ron chwadan ol zia chu in she thiam mayang achan chu a product a kha aron chot me lo a product engting e ron chuang ti kha achan chu Lucas resin a chon turbidity kha in siam thina kan siang hei turbid an ni a ppt ron in siam don white ppt kha ron in siam ang chu turbidity turbid solution kan ti kha ni ta film lo clear solution ani lawa chu ta chuanin tertiary alcohol kan ti chu engting e kan ti turbidity appears immediately it ruali ZnCl2 le HCl it rual turbidity ron in siam secondary alcohol ani chuanin maybe 5 to 10 minutes mo chuanin primary ni kha chuan kan heat practical tak phei chuan kan heat thin ta ma se kan heat lo ni chuanin kan stir chara chuanin eta after 30 minutes anga ti khan ronin siam thin ta ni kaima ni kan practical a khanin enge impurities te lo chuan mo amaro chu theory anga ta ka chuanin a time thap khan ron da ma se kha a time kha pui mo ber chuang lawa apui mo ber chu reactivity order in thiam chuan question pin chang the ni me hei question hi tiana ti theya ama chuanin lo se in syllabus hlui anga kha chuan la ring ola chuanin general principle and processes a po atel thei tho ni he question hi amaro chu tuna chuanin atel to lo wangin conserve le thona chu GOC a khanin heta principle ni lovun at techniques a zo khanin consider ta chuta chuanin chromatography kan tiang chi te crystallization te sublimation distillation kan tiang chi te kha consider ta mo chu ni ta only thing some solid substance change from solid to vapor state without passing to liquid state. The technique used for the purification of such solid substances based on the above principle is known as Arrhenius. Question here nula at technique ka direct in ronso. Question zong zong all berti direct question kan tiang chi khania. Enghinge chromatography to enghinge crystallization enghinge sublimation distillation in sha chuan chante ang chi khanita. Tuna zo chu enge solid form kan neya chu vapor state a kan chan tiranga tia tro vapor state a kan chan tiranga enge telowin liquid state a kan chan tirlawang direct in heta solid atang kan vapor state a kan chan tiranga chu tiang purification kan manna ta na process chu enge technique chu enge tia enge nyang sublimation ni me tro tiang ka chu har lo lo to ko ni chu sublimation masik ka switching kan tile lok tiang atamlo to gani process akha GOC akha nen sianga a techniques big akha ni na tamlo to ka practical big hi chu dule skip me ro ka ti china question pani ba ka ron chwa ngai don lova ka tia GOC a question pakha techniques atang ron chwa ka practical chemistry atang question pani ron chwa ka chuanin topic dangi zir phei chuanin a ron chwa ka kha chan the vele thota tengang chi te khom ta tamlo to ka chu wang chuan zir lo ula in time akha in minutes ya mangai sia skip mero ka ti chin kan ta ti swal atam vak lawang practical chemistry le GOC techniques be ka chuan mo zir lo to pakha ahim om ja chu adanga khazir ro adanga khan solid ro mo achan chu in solid thelo mai thei ni a techniques be ka kha chuan in atam sia 81 eta aniline atang question pakadaron chuaka aniline does not undergo Friedel-Crafts alkylation reaction class a constituent Friedel-Crafts alkylation acylation and thengai lo kan ti kha why achan chu an n nitrogen kan ti kha and thing kan ti chin nitrogen kan ti kha before it undergoes resonating structure akal ma in heta ortho le para alkyl group te acyl group te an lu ma kha nitrogen a khani heta group a khan lut ma sa thin kan ti khamo chuang khami group an ron lo wang khanin Friedel-Crafts alkylation acylation kha thleng mo em em a thleng ngai lo thleng tur kha chuanin heta a drastic condition kan tiang chi kha special condition temperature avak te resin va pek bel te an ngai china kan tia Friedel-Crafts alkylation acylation as a resin dang kan man ngai lo wangin a thelo tani aniline cannot be prepared to Gabriel Thalamide synthesis. Synthesis on the Gabriel Thalamide synthesis dena intiam em khatiro Gabriel Thalamide synthesis atangin aniline kan prepare ngai lawadi engi kan prepare chin achu aniline chu aromatic amine chania aromatic amines kan prepare ngai lawa engi kan prepare chin chu alkyl amine kan ti so kha kan prepare chin ani chuan aniline does not undergo Friedel-Crafts alkylation ti chu dik adi kan ti to panga abaga kha nangmanin hanin enve chinula chuta chuanin achana kha pakhat ka sei to adang tam tak po kha oma kha nangmanin lo in enve statement to aniline cannot be prepared through Gabriel Thalamide synthesis ti takhi ngi akal tlang thelo na chan kha kan en lok don ni chu Gabriel Thalamide synthesis chuanin hi kan neya sorry ka direct nga lang hei hi ni ta chu ta chuanin hei mi hi Gabriel Thalamide synthesis a kan siam ta ni mo Thalamide kha KOH ne kan react pot yang KOH ne base ne kan react pot a chu ta chuanin hei ron in siam ta ni potassium Thalamide kan ti kha chu ta chuan heta hian alkyl halides kan mang ta ni chu ta alkyl halides kan man chu RX kan ti thin ta R a hianin only alkyl chaw a thai heta hianin arai la man thei lo mo hei aman thelo halo orange kan man thelo alkyl halide cha on man the chuwang chuan in alkyl halide chu I man chuan helai atang hian enge isiam chua tur chu amine ani na chuta chuan I amine siam chua tur kha atira alkyl halide chau I mana aral halide I man lo chuan omche chu aniline chu engtika ma in siam don lo tin ani chu chuwang chuan in Gabriel Thalamide synthesis so it is used for the preparation of alkylamines only kan tia ani chuan enge kana statement hi enang statement 1 adika statement 2 po dika ingi kan option to statement 1 adiklawa statement 1 and 2 are option number 2 ni hi both statement 1 and statement 2 are correct dika adik don din ani chu anzo trap major product A and B form in the following reaction ani ta yani major product kantura niya in option hi 1 2 3 4 hi randa option tam PBr3 niya major product in thanganga chuan alcoholic KOH nenin react bokanga thanja gang katiang reaction akaron anron ti chapon a thui lo ko maya anron ti cho hawahi PBr3 nen PBr3 nen he reaction hi pan hi chuak tungko ma hian PBr3 nen alcohol le PBr3 je ka himo pakhat chu eta cho major product siam turania pakhat question pakhata chani by product ani tani tuna hianin kan nei tur chu nia OH aya BR da tur kan ti chin kha chan hi major product kan ti chu ni ta he bakin siam don lo major product ani chuan next a khanin engen lo da inang next a khan alcoholic KOH ania alcoholic KOH homzia chu elimination reaction tina elimination reaction chu po beta elimination mo chu koi nge in manang kan man tur chu hi beta ai chu oma ta hian beta ai chom boka ingi kan ti chen beta ai cha khanim nelami kan mang zo kang mo chan chu sei chef rule more alkylated alkane ron chak do na tian omanga CH3 anianga ta hian double bond omanga he ti hian mo chuan hi ti hian ron chaka chuan enge kan nei tak le na pakana chuan in hei inen kop thiamang chu mo a hi A ni a hi B ni don ti na ni chu ani chuan kan A chu enge kan nei kan A chu bromine le methyl cadmium ani chuan in hei dik theya hei dik the ti na ni chu B hei so B a chuan in bai don ta chu ta chuan in ka soi to kha hei helai mi in man chuan hei helai ka star mark H zo ka hi in man chuan hei hi in huang masengin hei hi in man ve thung chuan helai mi hi mo ka tik zo ka hi in man ve thung chuan hei hi in mu thunga chu ta chuan se je ru kan mang thina alkene chuan more alkylated alkene are the major product kan tia chu wang chuan in enge major product tur chu hei hi ni don tina ni hei r group exam nge nei pakhat tro HCC bon ha pani pathum nei tina ni chu identify the major product C form in the following reaction tinia hei hi enula CH3 CH2 CH2 ion NaCN nen enge hi eng reaction nge he reaction hi pakhana chani nucleophilic substitution reaction of alkyl halides ani a product kan ja ngal te ang a tur chu CH3 CH2 CH2 CN alkyl nitrile kan nei CH3 CH2 CH2 CN kan nei chu partial hydrolysis ti ru tia partial hydrolysis kan ti reng chuanin eitinge kan ti partial hydrolysis a reng chuanin cyanide group kan ti chu amide ta insiam thin sorry NH2 mo hei amide ta insiam don chuanin hei B ni chu hei mo hei A ni hei B chuan B chu enge NaOH nen Br2 helai mi hi Br2 tin mo hei Br2 nen ani chuanin hei hi eng reaction nge NaOH ani Br2 ni chuan hi Hofmann bromide degradation method kan ti chen ani cha he reaction a he intingi kan ti chen kha CO is directly removed kan tia tro ani chuan CH3 CH2 CH2 NH2 ni chuan hi enge ming hei hi propanamine an ti theya common name a chuan propylamine ani ome oh option number 2 ani hi ma katiang ang kha e athui lo lu tu khe reaction hi he chapter hi alkyl halide a hi halo alkanes halo orange in ziranga he hi alkyl nitrile kan tia hi hydrolysis parta nia hemite chapter a thau hyang kan zir chanin hi amine cha kan zir ta chuwang chuanin reaction pathuma kha question pakhata ronda tina nia I class ate pe chuan reaction tamlu tu ka kha in ti china khamo he teng ti thang tan chuan thil har ani me lo le hi en le no kang 93 the product A and B obtained in the following reaction respectively hi byproduct atanga ron chuak ani ta ni ni chuanin hei hi kaziak to pang o TROH PCl3 PBr3 ron manga ama che kan ti khan ama le a khan ni tuna cham PCl3 ron manga thil har ani chuang lova ta hianin ROH le PCl3 an neya A byproduct ron siama ROH le PCl5 ania chuta cham byproduct pakhat ron zo ta ni chuta chuanin A le B a hianin kan option ka kan endona ta hiam plus ta hin jang TOH nok eme PCl3 ne anga ta hian ani chuanin RCl2 kan main product ani a ani chuan ta hen ronin siam tur chu H3PO3 ronin siam mo chuanin panhina ROH le PCl5 ve thung anin react chuan RCl aronin siamanga POCl3 aronin siam do kaka kan product tur chu ni don tin ania H3PO3 respectively ron ti ro ani chan H3PO3 le POCl3 anon chuan chu option number A ani don tin ani chu hello wait a minute more for the reaction I the reaction po ka soi to a chu bang chuanin kan eng lo to lo bang hei hi in cha tanga chu ta chuanin alkyl halide alkyl halide se po ni se ti tiang alkyl halide se po alcohol te po aldehyde te po ni ta se hydrocarbons te thlengi the final oxidation product the major product kan ti reng a hi chu carboxylic acid se chu bang chuanin hei hi an product tur chu ni me carboxylic acid om chu na hi ma sengin product a hi an ron thak resin a hian ron thak ta keminophore ni lovin oxidizing agent dang ron da ta se ni chwa product angai to me lawang carboxylic acid kharon ni to don lo khalaya kha adang lam na keminophore ni chwani carboxylic acid ze ni don mo kha kha ni ta a tikhanin kan zo ta ke ma par bi ga chwanin kan du to kanga chuanin a topa ka soidu chu organic tun tuma mi hi chu a ol nu to ka chu wang chuanin organic chemistry be ka hi chuanin in deciding factor ni lo mai thei chan chu in thiam kha midang in an thiam ve thei tawa amaro chu subject danga internal physics anga te thiam hawa kha kha in kang dor ka ringa chu wang chuanin organic be ka hi chu ka soi fo thin ang kha ni class a in zira hi atok lu to ka ni ti kha an thar le don ni ha me
ole kan chun zom lenga karon ti tu path hi chu coordination compound le chemical bonding lamang chi kha le bimolecules kha karon kal dona bimolecules rang phe chon pakhate movel ba kha chok lo ta maro chu coordination le chemical bonding atang khan achok ve nuala khatiang chu kan en don ani chuan heng chapter atang hianin achuak thatei em maya thiam chuanin a ol boka a ol chuanin ai tiga nia mark kha ulsam tak takin score thei don ani chuan thil har sava ka om lova kan enanga kan thiam zungzung turanga yang tuna 54 hi kan chok chinang he hi statement way china ron thenta statement way chi ron thenta en bang taila CONH36 le COF6 aron titan hey magnetic behavior adang lam aron te statement 1 statement 2 wa chuan CONH36 hi diamagnetic ani COF6 hi paramagnetic ani ron tia kan en chin don ani CONH3 63 plus kan na ya ti chuan entaila hei hi formal charge 0 ani om zia chu CO hi plus 3 oxidation state ani ti na ni plus 3 oxidation state ani ti na ni ti chuan COF6 kan nei le COF6 ve thunga ro kha chuan 3 minus mo x ni ta se hei hi plus minus 1 f minus 1 ani ta into 6 equal to minus 3 nia x minus 6 equal to minus 3 x equal to minus 3 plus 6 x equal to plus 3 in tan om je chu cobalt in plus 3 oxidation state ve ve nei ti na ni ang ai nang lo lai tu ligands te hi hey strong field ani hey weak field ani tamai ni chu wang chuan han in wang tai la kan chok chinang ti chuan cobalt kan thia thawangin 27 this 27 atomic number 27 ani chu d7 system ani ti na ne mai ta ti chuan plus 3 oxidation state ani ta ni om je chu oxidation state hi plus 3 chuan electron pathum kan loss ti rangai don ti na ni outermost electron khan electron pathum kha kan loss ti rangai don ta hey 4s hey 3d kan en chinang ta hian electron pasari om don ti na ni d7 system chu electron pasari om ta ni ti chuan kan en wang anga electron pathum kan hlau tir don ani electron pathum kan hlau tirang electron pathum hlau ta se lai mi pahni le lai mi helai mi pahni le helai mi hi hlau ta se ti chuan engting exam elo mang khat ni thum li nga ru khati za thilo om don ani ti chuan en wang tai la helai hi strong field and strong field re chuan an pair tir thin ani an pair tir thin low spin complexes ani an pair tir thin helai mi rong kalanga heti lai mi rong kalang tai na ron lutang ti chuan a in pair na chuan a in pair chuanin a in pair up don ti na ni aron in pair up anga aron in pair up chuan unpair electron som lo ti na ni unpair electron sa om lo na chuan om zia chu diamagnetic ani don ti na ni unpair electron sa om lo chuan diamagnetic an ni ti na ni diamagnetic an ni ti na ni chuan diamagnetic an don ti na ni hei ve thung chuan en wang tai la fluorine ve thung ro hi chu weak field ligands ani wangin heti lai mi te hi pair tir don lo engma hi pairing kha heti aron lut tur kha om ve don lo om je chu unpair electron si pathumi nei ngal don ti na ni chu chatia mem ti chuan unpair electrons pathumi nei chuan unpair electrons pathumi nei chuan paramagnetic ani don ti na ni paramagnetic in nature ni don ti na ni ani chuan hei hi paramagnetic ani hei hi diamagnetic ani ve thung ta aom zia chu para le daya kan nei ta ni para le daya kan nei chuan engting statement ni ti statement 1 chuan magnetic behavior in a chen sanga atia adi khapa statement 2 en taila diamagnetic hei hi diamagnetic atia adika hei hi paramagnetic atia weak field ani adika ni yang hianin atina thei dan all some te khana ti thei ta ni ammonia en wang taila ammonia hi engeni strong field ligands ani hei hi engeni weak field ligands and weak field ligands na pair ti don lo atlang pui thuin paramagnetic ani hei ve tung chu atlang pui thuin diamagnetic ani adik ngal ngai tuare re puna dingal en wang pula magnetic behavior adang lam don sim boka chu wang trans both statement will be true next sakan kalang hanin le wang taila 55 fi 55 fi kan en chuan yang match the columns kan tiang che vela hianin hin thi tam em mai ta ni atam po le hin atam question na sei po le hin atam ti kha ria turani ti chuan en wang ta ila hey sf6 te kan lo nei ta ni sf6 hian en wang ta ila i thiam ta hen pakhat tal kha om don chiang ani ammonia te poi lo thiam thei hei te poi lo thiam thei mo heng te poi lo thiam thei akha ma ber hi thiam thei ni i thiam ber tang khan buli tanang i thiam ber khan buli tan ti rang ti chuan en tinan sf6 te hi octahedral ani octahedral kha lo ni tan sp3d2 hybridization ni octahedral ani ti chuan engeng d3 zu enanga d3 chu hei che d3 oma om je chu hei an correct answer ani mai hei correct answer ani hal don ti na ni mai ma se engting sf6 yan in octahedral ni thei kan en chuan sulfur hi valence electron exam ani 6 ania ti chuan monovalent exam ni om fluorine exam ni om paru ko oma divide by 2 it means 12 by 2 that is 6 to sp3d2 sp3d2 to octahedral structure ani ti na ni ti chuan kan en le lokang xcf4 hi kan en le lokang xcf4 ka kanena xcf4 chu nge kan ti chuan xcf4 chu valence electron 8 fluorine exam nge om 4 divide by 2 that is 12 by 2 chu 6 om ja chu sp3d2 thawani octahedral tur thawani amaro chu structure hanjia saktaila yan ni don ni yan structure kha om don ni ti chon om je chu hei plane na square plane na khan om ta ni om je chu square planar structure kha ron so ta ni octahedral kha ni thei tolwa due to the presence of two lone pair the structure will become square planar ani don ti na ni hei c chu true ani don ti na ni hei c chu true ma yang khanin aslum chu avek thei ni br f5 ani point br f5 po hi sp3d2 ania maro chu fluorine kha pakhataron ombel lenga fluorine pakhataron ombel wangin square pyramidal a chuak thanga nh3 chu kan threvek sp3 ania tronium sp3 nia pyramidal structure ani pyramidal structure ani don chu enge hei hela hi pyramidal structure kan muang khian tihan option kha ti zung tur ni hetiang hen time kha waste vak lo tur idu kha ithiam ber khai va mu chon alo ni lo thea tianin option kha itizim zung mai don ya let's go to next slide 57 kan enang glucose hei kan zirna sa achuak du reng pok hei hi glucose ina react thei lo khan omani hei chin chia tat tur glucose ina react thei lo hi in chin chia tat chuan boina kha om don lo fim hei ol sam takini crack ngal thei don tina ni chu entinan glucose tolerance reagent ne na react them glucose chu engatanga siam nge yang glucose structure kan mu chuan glucose structure khan nge kan mu CHO kan mu ni chu aldehyde ani aldehyde kha tolerance reagent ne nan react in enge pek thin silver mirror pek thin om je tolerance reagent chu kaldon chiang ani tolerance reagent chu kaldon chianga ti chuan HCN nen hian cyanide nen hian in reacta se enge pekang cyanide nena pek tuan cyanohydrin kan tiang chi kha ape the ani cyanohydrin ang kha pe the ta ni om chu hi kal le the ti na ti chuan NH2OH kal them NH2OH ne in react them NH2OH hydroxylamine kan tiang khan ta ni hydroxylamine ne in react chuan oxime kan tiang chi kha pe le the ta oxime pe le the ta ti chuan aom zia chu hei pe theilo NaHSO3 kan tiang chi te pe theilo wa skiff reagent nang te hi akal theilo bokani glucose yanin ti chuan kan option chu b le answer chu b le e hi kal theilo tinani om zia chu b le e chu engen yang this one tani kha zong kha ni match the column minute suwak du ang rank khop mai hemi chapter chu atiang chi match the column om re chong ka soi to ka hin kha tam kan ti kha en wangfang tan hyper kan zirna sa isomerism chungchang kha ni ta isomerism chungchang ani isomerism a chuan pali kan zira isomerism pali panga kan zira ti chuan kan isomerism zir te ka heyaron chuak ta reng bokani eti kan ti solvate isomerism chu nge kan ti solvate isomerism aron lan to reng chuan tuya om don hydration ani ti na ne hydrate ani tuya om don ti chiang em mai ta ni hei ta tuyom chun chu H2O om chun chu hei hi ni om je chu d chu engen yang 1 ani ti na ni d1 in zong ang he ti lai en d1 hem khoi mo zong hi ni don ti na ni ti chuan hale le bang tai la hei halin tai la c te po hi partner an in thleng ta en wangfang tala partner in thleng ang khani ta om zia chu coordination ani ti na ni coordination ni c hi 4 ani ti na ni coordination ni ti na hei hi ni don ti na answer chu hi ni don ti kha chiang sa em ta mar chu kan ti zo shimang hei en wangfang tala br heta na om ta br amo so4 bona chok bel tung ta se hei hi en tawla bromine le sulfate hi ionized dial ang thelo ba chu wang chuan ionization isomerism hoya ta le ta ti chuan en wangwang la chung hi NO2 hi ONO inaron om thei boka om je chu ambidentate ligand saron in so ti nani ambidentate ligand saron in so re chu unlink dan o atangina mo en atanga link thei ta linkage kha adang lam ta ni om je chu linkage isomerism ani ti nani om je chu option hi ai hi ni don ti nani kan move on intramolecular hydrogen bonding aron ti ta ni intermolecular hydrogen bonding chu tu nge nya intra chu nge kan ti chuan inside ani ta ni intra อันนี้ส่วน inside กันตีค่ะอ๋อ intra จูชุงลำบโบนันยา in hydrogen bonding ที่ inter และ intra กันเนี่ยกันตีค่ะ inter อันนี้เวทุงส่วนปนลำเอ็นตีนาน hydrogen เละเฮ้ยเฮติยังอังจีเตฮีเฮติไลฮีไฮโดรเจนโบเฮติไลตักฮีไฮโดรเจนบอนดิ้งกันตีค่ะในตานี่อ๋อเฮติไลฮีไฮโดรเจนบอนดิ้งกันตีค่ะในโดนตานี่อันนี้ฟังตลาอัมมาอังทูปักขัดเนียนอันนี้บอนเฮติไลนินบอนนั่นไลฮีไฮโดรเจนบอนดิ้งกันตีค่ะในตานี่เอาผมจะสู้อินเตอร์ขนาดเท่งตานี่อ๋ออินเตอร์อันนี้ตาอินไซต์ตาเท่งเราตานี่เอ็นที่นั้นอินไซต์ในตัวจวนเฮติยังจีเฮียนยังไงinside นี่ตัวส่วนที่ยังจีอายัน OH เต็นี่จะเสออร์โทโพซิชันเอาเฮียนักเล่นดูเลยจอลเฮ้ยอามาโมเลกุลที่อามาเท่านี้โมเลกุลที่อามาเท่านี้เฮ้โมเลกุลาเฮียนเฮ้โมเลกุลาเฮ้เอ็นต์บังกุลาเฮ้แต่เฮียน O และ H อินการเฮียนบอนด์รันเล่นตาเฮ้ที่ยังจีฮี intramolecular hydrogen bonding ตัวนี้itself inside อันนี้ itself อันที่บอกชินตานี่มีจุดนั้นเช่นนี้เห็นฟังตัวละ HF จุดเช่นโดนเราเจียงอันนี้เฮ้ example ก็เป็น intermolecular อันนี้เฮ้ยอันนี้เลยไตละอินหลัดลุตุกปารา position เฮลายาออกซิเจนเลยเฮลายมีอินบอนด์เฮลาจุ่มเฮ้แต่อันหลัดลุตุกันนี่inter ข้ากัลโดนเฮ้แต่พอละอินหลัดลุตุกันนี่ตรงนี้ในเบรังเฮ้เอ็นฟังตัวละ position เห็นตัวละเฮ้ ortho เฮ้มีปัจจุบันใน MM เฮียนี่อารมณ์แข็งเทโดนที่นั่นนี่เฮ้ยอินทรานี่โดนตีนะเฮ้ยเอ็นฟังว่าอุลาอันนี้ไม่เอ็มไล่เละอันพูดยังไงที่ขันโดนตานี่ไอ้หลักจวนอินเตอร์โมเลกุลาร์ไฮโดรเจนบอนดิ้งก็ละไอ้ในจวนอินเตอร์โมเลกุลาร์ไฮโดรเจนบอนดิ้งก็คัลชิตานี่เสียไม่ตัวง่ายยังให้ที่อันปัจจุบัน correct statement นะคะเจ้าท่าน statement ข้ารอนdirect question ข้ามังเลวท่า direct question นะคะตัวนั้นจน correct ดิกเบอร์กันทั้งสองตัวนี้ดิกเลวปฐุมตีน่านี่ไม่ตากันเอ็นชินัง dipole moment of number 4 dipole moment of NF3 is greater than that of NH3T dipole moment hi NF3 hi sang zo kati hi dik don law ni NF3 in NH3 sang zo don hay fiat tatur tizong na pot chawa dipole moment hi ankal rual ta hi chuan ta betung chuan tizong na pot chawa nitrogen I fluorine electronegativity san wang tizong na pota opposite side in kan sel molom thini chu wang chuan NH3 hi rin lo deuh main unexpected ang khanin atiang chi khan dipole moment kha sang zok tat me ni ti chuan BF3 hi non zero dipole moment atia diklo le boka BF3 hi zero dipole moment ani BF3 chu sp2 hybridization ani zia chu ti hian structure ani don ani 123 ya ti hian hey bond tanan pot darvek don ni ti hian changam yang ni chuan zia chu zero dipole moment kha zero don ti na ni zero dipole moment ani don ti na ni ti chuan option true kanen liang option true chuan resonance structure kha ozone hian resonance structure pathum mane ti ni chu resonance structure hi ozone in pathum mane rengem kan enang ozone hian resonance structure hi pathum mane lo ni patni chaw nei the ni ozone chu nge kan ti O3 kha ni ta ni O3 ozone hian resonance structure pathum mane rengem hey en ta ul hetin lo om don ta ni resonance structure in va mu chuan tian lo om don ta ni engpo chu ni se ti chuan in helaya hetilaya negative hi hetilaya double bond hi akal son theng hemi double bond hi in thak char the ni ji chu helai aron phei chon tan double bond ma tan negative charge om vele thunganga mo tan negative charge khaum vele nga ta hian double bond khaum vele thung don ni tian in thak thleng me don ni tian resonance ka kal thia structure pahni nei thei ta ni pathum ni lo in pahni anei thei ta ni ji chu hemi pathum mi kan rule out thei ti na ya dik lo vek ti na ji chu dik om chun chei ni to don ti na ni en wang taila CO3 2- hian in conical form pathum ane atia khi dikani kan en chinang conical form pathum kha nei don ta ni CO3 khanin tian om dona ti hian om don ta ron resonance structure kha kal theya ta double bond kha le theya ni lo pon hetilai zo ka khan double bond kha da le theya ti khan double bond kha akal sun zel the ni helai double bond kha tan akal theya lai double bond kha tan chuk khale theya conical form hi pathum lai kha nei don ni alon per kha cheng po chu lo ta se lo da ta ula hetian conical form kha akal zel the don ti na ni om chu structure pathum nei ti kharon so ka tum na mai ni ti chuan structure pathum chu ne ya hei hi adik don ti na ni number 99 he to ber ni to hang heta po statement hang bokin ron chuak le a statement hi anu war khop maya statement 1 statement 2 oma statement 1 hi kan enang statement 1 a CONH363 plus hi homoleptic complexion yeti a ti chuan NH3 4Cl2 ro hi chu heteroleptic ani ati ni enge homoleptic le heteroleptic kan hriat phot kha ngai ta ni homo kan ti chuan enge homo chu enge niang same ti na ni similar ti na ni same kan ti thin khan ta ni similar ti na ni hetero ani ve thung chuan enge niang different ti na ni hetero chu different ti na ni ti chuan ai nang don lo ti na ni chu hanin wangwang ta ula CONH360 ligand pakhat chawina siamani en taule ligand pakhat lirina siamani chu homoleptic chu ni nge maya heta bethung chu en taula ligand pahnin ang loina siamani to na chu heteroleptic ani ti na ni mai ta ti chuan statement 2 hian chia le taila CONH3 has only one kind of ligand sati adik rengalom ligand chi en taulai NH3 chi hi ligand sa oma ligands pakhatina siamani ti chuan CONH3 4Cl2 hi chuanin pakhat aitamane ati adikalom pakhat aitamane ligand si NTU ta hian ligand si Cl le NH3 ni ta tronium ammonia le chloride kan nei ta awom zia chu hei hi hetero ani hei hi homo ani ve thung ani tina ni awom chu he statement hi adik ve tina ni both statement 1 and 2 are true ti hi ni don ni tikhan kan clear mai tu ranga yang ale tikhan tikhan azawin ka sia khazong khani
Hello students, I'm Zawlbuk today. Voina chuanin NEET 2024 physical chemistry questions karon analyze dona questions som pasari aron chuka physical chemistry trangin kan sia thiam dan ber tuin ron explain katum don ni karon explain na tur booklet T1 ti khania chuan tuna kan tran hal mayang. You see question number 59 kan en chuanin the highest number of helium atoms is in aron tita option pali miron pe khonge helium atom tamna ber kan jong chol don ni option housing akian option number 1 kan en chuanin 2.27 liter of helium atoms helium at STP anita chuta chuan exactly helium atoms kan jon chua don chuan we have to know the number of moles. You see ama sabera chuan eng formula nge kan apply ang kati chuanin n is equal to n by na okay chuan n hi ang tinange kan ti chuanin it is the elementary entity elementary entity kan ti chuanin it can be the number of atoms ani thaya number of molecules ani thaya number of ions ko ni thaya elementary entities kan ti chuan tuna chuan question akin number of helium atoms mi zota chuan n stands for number of atoms in kan chokang chuan ama sa chuan engtinge STP chuan number of moles eng te kan zon chuang number of moles is equal to volume divided by 22.4 liters ani chuan engtinge ni don and is what is the given volume is 2.27 okay 2.271098 is going to be divided by 22.4 liters. What is coming out? Aron shock to 2 liter and liter is going to cancel, is going to come out 0.1013 aron shock. This is going to be the number of moles. And it's on next step, and done number of NIR here, I can put this value, okay? NIR, if I put this value over here, 0.1013, okay, is going to be N, that is the number of helium atoms, number of helium atoms. And it's going to be divided by Na. Oh, and the number of helium atoms so is going to come out 0.1013 Na karon so done. Oh, okay. And it's one. Let's see option number 2 again. How much Na is present? Option 1 at 1 in 0.01 Na ti kakan set suak to. Option 1 at 1 in number of helium. Number of helium atoms, so it is equal to 0.1013 Na ti kan set. Oh, what about in option 2? Option 2 again exam nga niyang, you see, 4 mole of helium atom, number of helium atom ka kan signal sa tani formula ron pa and each one what formula I'm going to use n by Na. Okay, any formula ka the same formula. Oh, is going to be number of helium atoms. So instead of n I can put 4. Okay, 4 mole. This is the number of moles. Kamang halt hey. Oh, and each one we're having NHE by Na. That means NHE is going to come out 4 Na karon shog don tani. Oh, 4 Na ron shog don. You see, which one is more? 1 le 2 can compare here in number of helium atoms. Of course, true here. Tamday zok kan hut hey. What about in option 3? Option 3 kaya nang option 3. 4U of helium atom. 4U unified mass. U stands for unified mass. Atomic mass unit. U stands for unified mass. U quantity. Mu quantity. Dalton quantity. These are all the standard unit to measure the atomic mass. Standard unit to measure the atomic mass. Okay, unified mass. And each one in 1U is equal to, what did we have in terms of grams? 1U quantity, it is equal to 1.66 into 10 power minus 24 gram. And it can see and each one 4U here and thing here to come 4U it is going to be equal to 4U is going to be equal to 1.66 into 10 power minus 24 gram divided by 1. Okay, divided by 1U into 4U kanidona. U le U in cancel lang. Is going to come out 1.66 into 4. It's going to come out 6.64 into 10 power minus 24 gram karon so don. This is going to be the grams. For U here in terms of grams and each one. This one is going to come out. And each one take kan tila don number of moles kay take kan zonang. Number of moles, you see, let me write over here. Number of moles, so it is going to be the given mass, okay. Given mass divided by the molar mass. So given mass, this is 4U is equal to this mass, okay. It is going to be 6.64 into 10 power minus 24, okay. And this is the grams. So what about the molar mass of helium? Molar mass of helium 4 ani. 4 grams ani. 4 grams ani. Gram and gram can cancel. And what is going to come out? Is going to come out 1.66 into 10 power minus 24. Karon so 1.66 into 10 power minus 24 on so dona. And each one the same formula. Let's apply. Number of helium atoms kan don't we know that the formula is equal to N is equal to NHE by Na. Okay. And it's showing any don NHE is going to be N is equal to this one. And it's showing NHE here and take an don 1.66 into 10 power minus 24 and current show down. You see 1, 2, 3. 1 le 2 le 3 can compare here kung lot number. Of course 2 ka lot number tro adota 1 here lot number number of helium atoms 3 here a lot number tani. Let's check option 4 here. Let's see option 4. I'll just write here tayo ka zero lang option 4 here 4 gram of helium atom constitution. What is going to be number of moles? Number of moles is the given mass divided by the molar mass. What is the given mass? 4 gram katitay tro 4 gram katitay. What is the molar mass of helium atom? 4 gram anitani 4 gram molar mass of helium atom is going to be 1 gram. It is going to be 1 karon shong tro number of moles so 1 aron shong dona. What about the same thing we'll use? N is equal to NHE divided by NA kakan apply electronin. NHE is going to come out, instead of N I can make it 1 tro 1 NA karon shong don tani. Oh, kamsha TMM is going to be like this. And each one, let's compare 1, 2, 3, 4. He compare tayo kung asang berdon, asang berturchu, 4 NA he asang bertro, 4 NA asang ber. And each one, option 2 he, it contains the largest number of helium atoms kat itay nitro. So what about the next one? You see, let's compare 1, 4 le, 1 le, 3 le, 4. He compare tayo la 1 at 1. This much we are having. Okay. 3 at 1. This much we are having. Of course, 4 naka. 4 kanin helium atoms are contained tam le berang adotation. What about let's compare 1 le 3 ka compare kan 1 is this one is very small. Draw is too small divided by 10 power 24 kanidona. That means 1 ka anile dona. Helium atom keng tam bertuchu. That means the last is going to be 3 here. Option 3 here. Option 3 here. Option 3 here. Helium atoms claim berdon tinani. So and each one, what is the correct option? Correct option is option 2. Okay, as simple as that. Hello, draw. Let's go to the next question. Okay. Whose reaction is not a redox reaction? You see, redox reaction to joining there should be oxidation reaction le reduction reaction ka ngai tani. Zia chu atom sa kanin atom kanin a reactant na atom le a reactant hawa an atom le a product an atom hawi element sawi element sawi whatever atoms, let's make it atoms. Okay, the charge kain ang low turani. If a charge sakata if there is an increase in charge we call it the oxidation. If there is decrease in charge we call it reduction. Okay, let's see. And don't option 1 kick and then in option 1 BaCl2. BaCl2, I'll write it again. Okay, BaCl2 plus Na2SO4 is giving BaSO4 plus 2NaCl. Hey, redox reaction ani nga nilaw chakang amasabera chuani we know that halogens they are carrying -1 charge and carry through and each one barium oxidation number ka zondo for BaCl2. Okay, barium oxidation number ka zondo I can make it 2 into -1 kati thro. Chlorine is carrying -1 charge, halogens also they are carrying -1 charge, and there are 2 atoms of chlorine. That means it's going to be like this through. Then the whole atom molecule is neutral. Okay, I will put 0. And each one x is going to be plus 2 around showing throw. X is going plus 2 around showing don't turn it. That means I can put plus 2 here. Okay. And each one chlorine 2, we know that chlorine atom pakadachon, we know that is carrying -1 charge. Is going to be like this. Na2SO4 ki kanan chuanin Na2SO4 kanan chuan sodium yanin. It is the first group element anita first group element chuan. They are all carrying +1 charge. Adis. First group element how they're all carrying +1 charge. Okay, what about sulfur? Hey, sulfur here exactly oxidation number how we have to do? SO4 polyatomic ions anitani is polyatomic ions. It is having the formula SO4 here, it is having the formula. Okay, if it dissociates into water, it's going to have the formula SO4 2 minus. Okay, and each one and don't sulfur here oxidation number is going to be sulfur. Let's make it x. Okay, x plus 4 into oxygen chuanin peroxide superoxide nilawa chuan compound dang zong chuan -2 charge an nei ti kam sia tro. Oxygen is going to have -2 charge. Okay, so heta a charge from here is going to be -2. Okay, heta the whole molecule is having a charge -2 minus whatever. Okay, we'll put here on the other side. And it's and x is going to be, this one is going to come out 8 is going to be 2. Is going to come out -2 plus 8 and is going to come out +6 and plus 6 and each one in sulfur is going to have +6 charge. Sulfur here +6 and sulfur in +6 and oxygen we know that we already know it is having -2 charge. Oxygen -2 charge and you see, and it reactant charge kan zong zawa barium sulfate hit test le barium sulfate here. What is going to be, you see, other than Hey, two group 1 elements so chuan in plus 1 charge an nei vekang hey sodium le sulfate ka and combine barium sulfate a betu chuan this one is not a group 1 element. Of course we know that heta hian ka soitong khan SO4 khan is going to have -2 charge an 80 kan sia -2 charge an 80 kan sia tro -2 charge an 80 kan sia. See, you see, and chuan oxygen is having ani chuan oxygen is going oxygen po hian -2 charge anei don ta ni apum pui sulfate po hian -2 charge anei whatever chuan ani chuan in -2 charge anei chuan what chok kher lo kan fia dan tur chu the whole compound BaSO4 hi neutral ani ta ni hei hian in -2 charge anei chuan -2 charge anei chuan barium hian in +2 charge anei yang ti ka fia tur +2 charge anei yang ti fia tur barium. Because barium is not group 1 element. And it has group 1 element SO4 -2 charge low neta Na3 +2 katingot thelo. We know that group 1 element should +1. Other than group 1 element, barium to group 1 elements and lower one, we just have to remember like this. Okay, if it is having -2 charge sulfate here in the whole atom to be neutral, barium here you have to have +2 charge. Okay. What about NaCl? NaCl and what can we write? See, sodium, chlorine, halogen sum -1 amniti kan sia. Sodium oxidation number lo zong don taila. It is going to be +-1 and and the whole molecule is neutral. Okay, and we are going to have sodium to -1. If coming this side is going to have +1. +1 is going to have chlorine to -1 and it is halogens. Let's check ang to na chuan barium hi taila barium is it changing its oxidation number oxidation state at change sem barium atom sa hianin a charge I change sem a reactant le product I change lo tro +2 level ani let's see chlorine point change sem chlorine atom pakhata hian enge charge exam yom -1 tapo -1 tho tro I change yong lo chlorine po. What about sodium po anila +1 +1 ania heta po +1 tho sodium atom po oxidation number in change lo tro sulfur po in change lo +6 this is going to be +6 heta po +6 ania if we calculate it's going to be +6. Okay, let's see calculate sinang barium is having +2 charge. Okay, +2 charge plus x if I'm going is going to be 4 into -2. Okay, 4 into -2. The whole thing is neutral. Okay, is going to be 2 plus x 4 into minus is going to be -8. Okay, is going to come out -6 plus x around so on. Is going to be x is going to be +6. Adik khap sulfur poka +6 around so ani sulfur poka oxidation state is not changing. Nothing is changing. In atom mine an oxidation number can change now. Oxidation number increase lower decrease low. So this is not a redox reaction. Redox reaction ami only BaCl2. The first reaction is not a redox reaction. Okay. Let's see. Second reaction, third reaction, fourth reaction. Hati chodu alo hianin redox reaction ani ti kha asiat ngal mai ni. Asan chunga tinga en sinang second reaction la third reaction la fourth reaction kan em dingot bukan redox reaction ani ti asiat thai ngal mai. Asan chumo zinc elements ka a free state elements ka in combine lo we used to say the oxidation number is 0. Okay, zinc in mana in combine lo a free state no ma 0 ni heta chona in combine ani zinc something is going to combine. Of course there is going to be heta hianin plus ani nge dona plus something whatever chokharo ko khanin just have to common sense atang zinc is going to increase oxidation khaum nge don oxidation khaum nge don zinc ka khian. Okay, what about copper sulfate hian chuan let's see copper hian taila hello product of me copper heta in 0 ni entro 0 ni do copper sulfate hian chuan is going to have something plus value kha nei do sim is going to ani chuan hei chu enga ni don reduction of don tinani chu du chuan na chaw thak bek how much but it's wastage of time exam na chuan just seeing from the question we can know of course ani chuan reaction to redox reaction ani don ni chu. What about option 3 can let option 3 point is very easy. Hey 0 ni dona hey point 0 ni dona chlorine here time is going to have plus something oxidation number chlorine here and chlorine is undergoing plus time 0 calchuanin is going to be oxidation number is decreasing, tinatro. If oxidation number is decreasing, we call it reduction. Oh, reduction of don't tinani. Option 3 chlorine is going to undergo reduction. Iodine here and methyl iodine here, after say that one 0 that one is going to have plus something value can I don't tani. Oh, 0 taya kaljuanin hey oxidation kan tiang tro. See again, that one reduction le oxidation le don't tinani chu kan het mem ikan. You see, ani le reaction 4 ken taila hey 0 veven yang tro H2 le Cl2 0 veve kan ni don't tani. We know that hydrogen 2 oxidation number 2 plus 1 and they can share. Oh, like rules of oxidation number. From that one, we know that hydrogen is the oxidation number. Like is plus 1. Okay. What about chlorine? Chlorine 2 halogen 2 minus 1 they can share. Let's see. Let's check. 0 tanga plus 1 calcium increasing oxidation number. Draw. Increasing oxidation number niyam. Hydrogen is 0 time plus 1 akala is going to be oxidation. Draw. Oxidation. What about chlorine? Chlorine 2 0 time minus 1 akala 0 nge minus 1 tamjok 0 tamjok draw. And it's one oxidation number is decreasing tinanium 0 tanga minus 1 akal oxidation number is decreasing tinatro minus 1 so is going to be chlorine is undergoing reduction. Oh, hydrogen is undergoing oxidation. Okay. Chentro. Chuan and it's one option 4 redox reaction to redox reaction to one here. And it's one option 1 okay redox reaction and tinani chu. Okay, let's go to next question. Next question You see, question number 63, comment 1, let's list 1 with list 2 at the you see, what are the process, thermodynamic process, list 1 up there, what is the condition of that process? List 2 up there. Oh, you see, and it's one isothermal process. Can it one isothermal process? It will be is going to be carried out at constant temperature. Through isothermal process. Isothermal process is going to be carried out at constant temperature. Oh, isothermal isochoric condition is going to be carried out at constant volume. Through is going to be carried out at constant volume. Okay. And it's one, what about isobaric process is going to be carried out at constant pressure. Throw isobaric too. Question harsabak lo poyer on show but this is very good. Till harsalo class I chintoang. A diabatic process too, no heat exchange no heat exchange between system and surroundings. So delta Q is equal to 0 in a diabatic process. No heat exchange between system and surroundings in a diabatic process. And each one, this one is going to be option 1. Is going to be number 1. Okay, a diabatic process. And each one entire A matches with 2. A matches with 2. B matches with 3. C matches with 4. Okay, B matches with, and each one option 1 here in don't tinani. As simple as that. Okay. Next akalang One gram of sodium hydroxide was treated with 25 ml of 0.75 molar HCl solution. The mass of sodium hydroxide left unreacted is equal to mass of sodium hydroxide left unreacted means zota. I'm sorry. Kalay kasi you see, sodium hydroxide left unreacted at the sodium hydroxide excess reactant and don't teach young draw. Hydrochloric acid jockey it will be the limiting reactant. Okay. Let's see, can prove you see, and what we are going to do, mass of sodium hydroxide left unreacted kin is zota. Sodium hydroxide mass ka kan mo chuan formula ka number of moles formula ka kan mole concept tang aron kalani mole concept tang aron kalani I'm sorry amami ho ka aron kalna chapter ka karlo sailo pala whatever this one is coming from mole concept. Okay, and each one is going to be n here and on given mass divided by whatever given mass or required mass what is the mass required mass divided by molar mass. Okay, this is going to be the required mass of sodium hydroxide which is left unreacted. This is going to be the molar mass of sodium hydroxide. Okay. number of moles si Sheila WE ka khamay don lomdro molar mass of sodium hydroxide kan khasabuka molar mass of sodium hydroxide kan khasabuka okay ani cho ente kan ti don you see number of moles of sodium hydroxide here ente kan share don firstly I'm react makan chuan in HCl ni I react makan in let's see sodium hydroxide ki number of moles zong chinang number of moles kan zong chinang 1 gram is given the mass of sodium hydroxide 1 gram is given okay ani chuan molar mass of sodium hydroxide chu how much sodium pakhat le sodium pakhat le hydrogen oxygen pakhat le hydrogen pakhat na chu is going to come out 40 gram per mole karon shogdon 40 gram per mole aron shogdona 23 plus 16 plus 1 okay is going to come out 40 gram per mole okay and each one what did we have 1 divided by 40 1 divided by 4 gram le gram and cancel now 1 divided by 40 is going to come out 0.025 mole karon chung this is going to be the moles of sodium hydroxide before it reacts with HCl and react makan and each one let's see HCl ki number of moles zong let sinang number of moles zong let sinang you see HCl ki ite number of moles ka zon thai don what is given in the equation volume le a concentration molarity in pedro volume of HCl le molarity of HCl in pair chu wang chu ente ka molarity is equal to number of moles molarity of HCl number of moles of HCl divided by volume of HCl in liters okay in ml ani chuan ml in ron petro volume ml in ron pe so we have to the formula is going to be into 1000 okay it's going to be 1000 ani chuan NaCl acting ani don NaCl okay I'll just write it direct NaCl molarity into volume divided by 1000 yang tro molarity of HCl is how much is given 0.75 okay 0.75 molar karon pe is going to be volume is how much volume is 25 ml okay it's going to be divided by 1000 okay it will be divided by 1000 and it's going to come out 0.01875 okay 0.01875 you see hey ka chona chan chu number of moles of sodium hydroxide number of moles of HCl ka chona chan chu mo of course we know that sodium hydroxide is the limiting excess reactant and HCl zoki limiting reactant ani hey excess reactant how did we know question here ron soi to thoma se let's try to prove it NaOC excess reactant ani ngayam HCl zoki limiting reactant ani ngayam just the simple formula number of moles of NaOC is how much we are having 0.025 kan naitro what is the you see the reaction kan zia chon mo NaOH plus HCl reaction kan zia chon is going to give NaCl plus H2O ay balance ka pem sodium ay balance pero oxygen point balance hydrogen point balance 2 hydrogen chlorine point balance 1 chlorine ay balance ka pani ki a balance chemical reaction okay stoichiometric coefficient of sodium hydroxide kan chon 1 omang pero 1 omang kadita is going to be 1 okay 0.025 okay what about for HCl can let HCl 2 number of moles is how much we're getting 0.01875 okay 0.01875 you see divided by stoichiometric coefficient of HCl is 1 pro 1 anita is going to be the same thing 0.01875 of course kung a ratio kung tamzok chu 0.025 tamzok pro is going to be the excess reactant tinan may excess reactant is going to be a ratio I mean with the stoichiometric coefficient the number of moles between them the ratio atamzok excess reactant this one is going to be the limiting reactant okay karhethiam tro ani chu ne kam ti thei don ta khian heta hian enge ka man don hey ka mangot thailo 0.025 ka mangot thailo because this one 0.025 is before the reaction of NaOH la HCl in react number of moles kani and react mo ka making a number of moles kan kan zon suang heta ka man turi enga ni don you see ta mi rap me ngo so ete kan tiang n AOH after reaction with ACL see ka je kharang o achian nan after reaction with ACL okay this one can be NaOH before reaction with ACL na in react ma number of moles after reaction with ACL so number of moles exact nga low ni don exact nga bang atiram yang ngor ka 0.025 ngor ka ito don it is going to be 0.025 minus what is the number of moles of ACL 0.01875 yang and it's going to come out 0.00625 karon chong you see like NaOH na ACL in thian dun kha lo ni taula mo NaOH na ACL kha thian dun lo ni taula nang ma ni thian dun ni ta se nang khan in cheng za nei ta la nang in cheng za in ya I thian pa khan in cheng som nga nei ya tunga nei nga jok nang ma khan nei nga jok poisa nei nga jok I thian pa cheng som nga nei ya you are the excess reactant okay I poisa kha zo har zo ang tro cheng som nga ve mang taula cheng som nga ve manga dora in kala chau ne cheng som nga man example la bang nang ma la bang tur chu 100 minus 50 in man za kai nang in man za thian dun in ya in thilai za point ang chi ang khanin like is going to be 50 la bang tro cheng za tang khan ani chon he vetun chu limit he excess reactant nang ma poison inga jokha this one is going to be the limiting reactant or thian pa jokha example la bang som nga man chau kha e ve tha ka ani chon eng ma nei to lo tro a zo va kani example apaman pui like let's see chemical reaction a chon limiting reactant a zo zel tani after the completion of the reaction okay ani chon example lo contribute som nga man khaya khatim chi khan let's see atira khan example nei atira khan 0.025 athian pa khan chau som nga man ya athian pa example man athian pa man ang kha mang ve example la bang som nga la bang khan 0.00625 kala bang tiang do chon me ani chon eng ti ani don instead of this let me rub again and rub le lock anga ani chon ni here what can I use ni here hey ka mang after reaction okay ani chon ni here ki kaman chon 0.00625 okay hey kan ma mo kha ni ta kan ma mo kha WNaOH okay mole of mass of sodium hydroxide we know that it is 40 gram per mole okay 40 gram per mole and what can I do hey cross multiply la 0.00625 into 40 is going to be WNaOH kanidona what is going to come out 0.25 grams current so 40 into 0.00625 to 0.25 grams around shogdona 0.25 grams around shogdona but when you see the question I mean the options grams in in talotro gram ka milligram unit tezo ka convert don chuan in I have to multiply by 1000 tro 1000 because 1 gram is equal to 1000 milligrams okay gram ata milligram ka convert dona and it's going to come out 250 milligram aron song 250 milligram aron song as simple as that til hareng mom lo cho okay is going to be 250 milligrams let's go to next question akalang you see which of the following will be a Kp and Kc are not equal Kp like Kc This chapter is from the chemical equilibrium. Kp le Kc, they are the equilibrium constant kanti kha anne Kp le Kc equilibrium constant chu it can be Kp, Kc, Kx te om thai kanti ang khana whatever. Chon a equation here nga means in which of the following equilibrium Kp and Kc are not equal. Kp le Kc is equal to chonin what's the condition? What is the formula? Kp is equal to Kc RT to the power delta Mg. We're having like this. Draw a formula how we're having like this. Kp is equal to Kc RT to the power delta Mg. Okay. And it's showing delta Mg value here. Delta Mg value is 0. Kp is equal to Kc RT to the power 0. Anything to the power 0 to 1. Draw. Anything to the power 0 to 1. Oh, what are you going to have? Kp is equal to Kc. Kalau na yang draw. Adigam. Ani draw. Anything to the power 0 to 1 ni RT hani pumpuyan 1 at dona Kp is equal to Kc kalau na ito. Ani chuan reaction how ziya ken delta Mg equal to 0 hawa chuanin delta Mg equal to 0 hawa chuan Kp le Kc include vekang ani chuanin enga kan ti tur Kp le Kc include lo na zong rotia delta Mg 0 ani lo na you see a reaction 1 en taila delta Mg value kan ani yang hey delta Mg kan ti chuanin enga kha number of moles of gaseous product, number of moles of gaseous product, number of moles of gaseous reactant, okay, is going to be option 1 can in how many moles of gases, gas vector, homogeneous gaseous reaction, vekanita, 1 draw, number of moles of, see, 1 mole of Br, 1 mole of Cl2 is going to be 1 plus 1 is going to be 2, 1 em, draw, reactant apo yan 2 1 em, 2 moles of BrCl gas and draw. And each one is going to be 0. And each one heta here in Kp le Kc ka include don and each one answer and it no. Kp le Kc include don tin and each. Whatever like option 2 ka and chintaila option 2 again delta Mg value 2 option 2. This one is for option 1. Okay. Option 2 tan chuan in delta Mg value 2 moles of gas in the product row. Product minus reactant 1 is going to be 2. Okay. 1 mole of PCl3, 1 mole of Cl2, and each one reactant here, 1 mole of PCl5, they draw, is going to be 0 on show, don't draw, delta G value 1 on show, and each one take a method on, Kp is equal to Kc, RT to the power 1 and idona, Kp like Kc ka include low draw, Kp will be greater than Kc, tinani, they, that's it here, ma'am. And it's in option 2 here in Kp le Kc and include low tinani, a question Kp and Kc are not equal. Option 2 here and don't tinani. Option 3 therefore kitsak taila 2 minus 2 and don't 2 and 2 minus 2 is going to be 0. That means Kp is going to be equal to Kc. Okay. What about option 4 kian taila? Option 4 upon 2 the 2 and here a product a reactant point taila CO plus H2O gas, there should be plus on to is going to be 2 moles is going to come out 0. That means Kp is equal to Kc. Okay, as simple as that. Okay, let's go to next question. And it's option 2 ka dignani don it. Okay, you see, question 72 can in which of the following process entropy increases? Entropy ka kung increase ang entropy teacher ng omzia. Measurement of randomness or disorderness. Ani nuai khan direction big lawa gas particles ka ang khanin. Entropy ka sang and the chain. ZT2 classroom light one it will be ordered. Okay, discipline the port china. Yeah, entropy is decreasing tinani so in order and this order your entropy is increasing. Okay, entropy is a measurement of randomness or disorderness kan chetur. At this order po, the entropy is sang don tinani chu. You see, option A kiyan sinang entropy denoted by S. Entropy denoted by S. Measurement of disorderness timang. Disorderness is sample entropy sang don tinani chu. Okay. And each one, what will be the change in entropy? Each one delta S come in them. What is going to be the change in entropy? You see, entropy. Liquid atanga, it evaporates to vapor, it evaporates to gas, liquid atanga gas akaltina. Oh, vapor to gas and liquid atanga gas. You see, kasi turchu solid han particles ka the arrangement is the most ordered. Oh, solita here in particle arrangement ka ordered better. Solita ordered better. Oh, solita most ordered. Okay, most ordered arrangement. Most ordered arrangement of particles in solid. Okay. Ado ta chuan in liquid ani yang liquid chu ado le chuan gas. Oh, gas. You see, liquid is in between solid and gas. Oh, the gas are chuan most disordered. Okay. Most disordered between solid, liquid, like gas. And chuan kat akan siya turchu most disordered are chuan in gas akian in entropy sang bertinani and you don't throw entropy sang bertinani don't. What about entropy? Entropy chu? This one will be the highest. Okay, gas are sang berang. Oh, gas are. I mean entropy in terms of entropy. Okay, I'm sorry. Gas are sang berang liquid next solid. Okay, in terms of entropy. In terms of entropy, chuan gas sang berang liquid next solid. Okay, order pole disorderness claim don tinania entropy claim don tinani. Ani chuan let's see option A can liquid to gas and ani chuan change in entropy is it going to increase or decrease? Liquid to gas and chuan change in entropy delta S is going to increase or is going to come out positive. Entropy is going to increase. Then this says entropy is going to be positive. Okay. Entropy is going to increase sinani. Entropy is going to increase sinani. Oh, liquid to gas. It is more disordered than liquid. Okay. And what about temperature? Temperature of a crystalline solid lowered from 130 Kelvin to 0 Kelvin. Let's see. Alumatangin, I mean, alumatangin avotakal don tinani to 130 Kelvin to 0 Kelvin. You see. Column light joining, let's see, can energy po asang zoka. Mostly, like can move about, can just on pay, kuwa vot joining. Tempe a vot lu tuwa kat se thalei thei lo mo korlum te kan ha kan tom im thin ro in chunga de kan om thin khatiang dau khanin you see temperature a hiam chuan atom imang kha crystalline solid a particle so kha there will be more ordered temperature a hiam chuan in a freedom of movement kha claim don tinani chu temperature san khan chuan freedom of movement kha atamang of the particles of the crystalline solid. Okay. And it's all entropy sang 130 in a freedom of movement sang temperature sang temperature entropy is directly proportional to temperature. Okay, temperature sang entropy poka sang. You have to remember that one. Okay, and it's all entropy is going to decrease. Entropy is going to be more here. Entropy is going to be less. Okay. Temperature here, and it's there is going to be decreasing entropy. Entropy, there is going to be decreasing entropy. When temperature change from temperature sangata temperature here, entropy is going to decrease. Because temperature sanga entropy sangzo. Okay, and it's option B here, the process entropy ka increase value or decrease. And each one, let's see, option B, we can cancel out. And each one option C and Taila. You see. We can do it like this. And then I have to point out the solid atomic gas. Some of the products are gas. Solid atomic gas entropy is going to increase sinanium. And it solid atomic gas. Some of the products are gas. John entropy is going to increase sinanita solid atanga gas solid atanga gas solid to gas entropy is going to increase. Say entropy is going to be positive. Okay. Or we can explain it like this. See, number of moles and Taylor are written here. Number of moles 2 anitani. What about the product? Number of moles 2 1 2 3. Okay. number of moles ka product ha number of moles sa tamjok tro number of moles chu a reactant na chon 1 ania number of moles of product chu 1 2 3 okay we have three products okay we have three products like this we are having I mean number of 2 to 3 number of moles atam chuanin entropy is going to increase, disorderliness is going to increase, disorderliness is going to increase, entropy is going to increase during this process. Student po kan claim chuanin ZT2 in a control ne chowa min control ne student tamlu tuk chuan ZT2 in control ne lawa disorder an chanu anoya random min anoma du na chen khulama kala helama chen an kala just like that entropy ka increase zon tinani chu student an tam chuan tiang dau chuanin number of moles atam chuan entropy increase zon tinani chu as simple as that. What about cutting kan option D po kan taila number of moles kung etam zo guess to guess kan ita guess to guess but the number of moles here tayen one anita tro stoichiometry coefficient number of moles 2 anita number of moles is increasing ani am ta po yan number of moles is increasing tro hey 1 ania hey 2 ania that means entropy is going to increase number of moles is increasing number of moles is directly proportional to entropy kan ti thai ani chu number of moles atam chon entropy increase ang ani chu what is going to be the answer which of the following process increase increase entropy increase acd ani chuanin option 4 ka answer ani don ni chu ani pathuwa b akin chu entropy increase velo okay let's go to next question you see for the reaction yes last question ka thermodynamic chapter ta ron kal khane entropy te kan zithing ka thermodynamic chu this question for the reaction 2A plus B at a given time the composition of the reaction mixture this one reaction process okay we can know that it is coming from the equilibrium chapter this one is equilibrium constant equilibrium chapter chemical equilibrium changaron kalani ti kan khathayang hey enge a base kan chana tur chu let's alias principles atang khan kan chang theng let's alias principles atang kan chang thaya let's see whatever let's try to attempt and tinan you see kc value here let's try to do that QC value rate constant equilibrium constant below chemical reaction constant dang zong ka we call it the reaction quotient okay QC equilibrium constant below zong ka chu we call it the reaction quotient okay ani chon reaction quotient here ta hian he reaction a hian ang te kan ti thayang he reaction and reaction quotient ang te kan ti don see reaction ni khoi lamang nge akal forward nge backward reaction forward nge malampang join nge lampang join akal kha kan khe duwa option ai min zota ate kan khe don kan khe dan tu chimo a qc value reaction quotient ka exact nge ni ti kan khe phot angai qc value chu nge ni don qc value if you see the reaction qc value chu concentration of product a product chu nge b le citro concentration of product divided by concentration of reactant concentration of reactant to A the stoichiometric coefficient it will come to the power tena dictro and it's what did we have A B again question I'm being given concentration of A B and C equal to 10 to 10 power minus 3 min petro and it's on B I can ka zia thai 10 to 10 power minus 3 ka zia thai C I apo can ka zia thai 10 to 10 power minus 3 ka zia thai and it's on like A apo here ka zia thai don 2 to 10 power minus 3 thau ka zia thai tro the concentration of same but it's going to be square okay fin kurturo square is going to be square and it's on like hey ka cancel back thai dro ka cancel back thai ni 10 to 10 power minus 3 hi pa hiyo mang khani ta square chung min cancel back thai what is going to come out 1 ka ron show do yan 1 ron show dro qc value chung 1 ron show don tinani cho nge a condition nita according to Lorentz principle sa chuan ante kan nei whenever qc is greater than kc KC value hi min petro question QC value 1 ani ti kan chok chok to ta tro chuan KC value ke nge 4 into 10 power minus 3 it is going to be 0.0 I mean 4 0.004 khan idon ta khunge tamjok 1 khi tamjok tro ani chuan in QC is greater than KC ka ti thayam 1 is greater than this much KC value to this much given in the question QC is greater than KC ka ti thaytro ani chuan what did we to study kan zitrim chu whenever QC is greater than KC the reaction will proceed in backward okay backward direction backward direction akalang backward direction akalang you see chimro what antinon QC value ka antinon ani chon hemi question big achon reaction has a tendency to go in backward direction option 4 here ni don't tinani chu antinon QC value ka low tlem ka jok ta se QC value ka low tlem ka jok ta se KCN kan cho chua kha KC ka equilibrium constant ka low sang ka jok ta se ani chon reaction will proceed in forward direction okay FW reaction will proceed in forward direction okay so whatever the anile QC is equal to KC ka lo chuak ta se ate ka ti thin kha hey equilibrium condition ka ti thin tro QC equal to KC it is going to be equilibrium okay equilibrium condition okay ka chin che to as simple as that ema thil harom lo cho let's go to next question okay you see Henry's law constant KH value of 3 gases in water are Henry's law constant KH value ka min pair KH value min pair the solubility of these gases in water follows the order A B C ki KH value min pair chon A B C ki kung soluble berang kung dissolve na sa thei berang kung number of moles in solution ka tam berang A moles nga B moles nga C moles ka solution tam berang kung soluble ber ti min zone ni chu number of moles of solution tam ka solubility sang ti nan me ai dissolve na sa ti nan me ti nan ta hemi hi solution chapter tanga ron kal khani solution chapter tanga ron kalani ani chu enge kha kan teaching ka enge KH value asan chuan KH value asan chuan in solubility will decrease kan teaching tro adiktro KH value Henry's law constant asan chuan in solubility decrease ang kati natinga chan chu mole fraction of gas is inversely proportional to KH okay mole fraction of gas le KH ki inversely proportional mole fraction of gas antinon mole fraction of A hi solution atam chuanin that means A ka solubility sang ti na ni me mole fraction of A solution khan A atam chuan A ka in dissolve na sa chuan B ka patni cholom ta se A ka pali dissolve ta se that means A ka solubility sang zok ti na ni chu mole fraction of A is higher inside the solution okay as simple as that okay ani chuan let's see ani chuan Henry's law constant is inversely proportional to mole fraction. That means we can say that Henry's law constant is solubility is inversely proportional to Henry's law constant. The same thing. The same thing also itu may nangrang ani chuan Henry's law constant kung sangber chu A B in water are this much respectively. Again a sangber tro A kia niam berdon tinani chu kung eklember Henry's law constant B kia solubility sang berdon tinani chu ani chon adota enge C an intro C kia niam adot le chon A ki Henry's law constant atam dara ani chuanin solubility niam berdida ani me this I'm sorry BCA okay BCA ma'am option 3 kani me as simple as that let's go to next question kan zau trap you see on heating some solid substance On heating, some solid substance changes from solid to vapor state, solid to gas cycle tinani cho solid to gas cycle. Without passing through liquid state kaltang lawin, solid atanga liquid kal lawin. The technique is for the purification of such solid substance only. I mean, process through technique called sublimation. That is the sublimation. I mean, like solid to gas through sublimation. Sublimation. The principle is not a sublimation. Okay. What about solid to liquid? Akalta se enge kanti. Solid to liquid akalta se. Solid to liquid akal join melting kanti le mayo. Solid to liquid melting, solid to gas sublimation. Okay. These three, hami patumi chu 1, 2, 4. Okay. Chromatography, crystallization, distillation. It is a separation technique. Separation technique and separation of mixtures, separation of components of a mixture. These three are separation technique. Separation technique. Separation of components of a mixture. And each one is going to be the option 3 key dignatida, and it don't to solid to gas akalatia without going through liquid. It is known as sublimation. Okay. Let's go to next question. Activation energy of any chemical reaction can be calculated if one knows the value activation energy. Activation energy too. You see, activation energy too, and can calculate activation energy of any chemical reaction can be calculated if one knows the value. Option so again, kung adik don. You see, I'm saying activation energy like see, we have the energy versus the progress of reaction. This progress of reaction. We have like this x-axis of progress of reaction. How it's going. And it's like. Energy with the let's say high vela have level vela here we have the reactant we have the reactant let's say like this, like let's say level product with us I'm sure. Let's make it higher. Headline reactant metaseta product. What is to happen? It used to go with the energy graph like this. Energy graph. Ito kan ni. Ini om jet ahian ni reactant niya ay product anita. Let's make it a line like this. We call this one reactant atanga. This one transition state. Okay, transition state. Hang turkanin. It needs some activation energy. The energy gap. Transition hang turkanin needs some energy. Okay, we have to supply internal energy. Internal energy na isang reactant kianin. Atok low. Potential kan ay exam na po. Exam mason turbon tiam thay na kan ay masa lekha ka zircho na tok low. Lekha ka zir ngay long. Lekha zir zat ka. Hey pass mark mita sen ni tunan. Exam ay lekha zir. Potential chu tiam thay na chu na isa internal energy om sa. Kinetic energy le potential energy na isa katina ni chu. Ani chu nin hey ale khazir pay le ale khazir pay na level ka level sang chu hin mita se. Transition state need a need true natur energy pass ma kanita sa ale khazir pe na kha activation energy extra energy kha amei kheng lo tro hemi level ni ta sang chon hey a kheng phalo kai na kheng phalo reaction ka kal thei lo aron le me yang and chon the extra energy which a molecules which a reactant must have extra energy, this extra energy to reach the transition state and forms the product. That extra energy is called the activation energy. Okay, activator is called the activation energy. Let's see. Threshold energy. So threshold energy ne student tamta shed polchina. Hey, threshold energy is going to be the EA plus the internal energy. Let's make it U thing U2 is the sum of potential energy plus kinetic energy. E threshold 2 it is the sum of activation energy plus the potential energy and sa potential energy may sa lo sang chon R here ta hian 0 hian om de okay potential energy and sa potential energy and sa ba ka khanin the activation energy apum pui threshold energy kan ti chu okay let's go to the question activation energy I think a calculate thai aron tita isi Arrhenius equation ka Arrhenius equation ka kan ngai to chuanin the equation Arrhenius equation number 1 2 it is given as k is equal to a e to the power minus a by rt kan nei thin tro we are having like this Arrhenius equation rate constant is equal to the frequency factor okay into the exponential of activation energy okay this one gas constant this is temperature okay this is what frequency factor this is the rate constant we are having the Arrhenius equation like this okay equation expression different forms of Arrhenius equation Arrhenius equation ka tisang kan modify thaya like mase ka soi tum chu ta hian ang tinga ni don activation energy ka rate constant at two different temperatures at the point another form of Arrhenius equation too we're having like this log k2 by k1 okay log k2 by k1 ea by 2.303 r 1 by t1 minus 1 by t2 dictro like this we're having this is another form of Arrhenius equation and then equation option rate constant at two different temperatures this is the rate constant at temperature t2 this is the rate constant at temperature t1 hemi pani sheila activation energy ka thayang tro temperature po kan shia rate constant k2 le k1 is taila rate constant at two different temperatures if one knows the value of the rate constant at two different temperatures rate constant and then 4 lo ni ta say 2 ni ta say 4 by 2 2 log 2 kha lo ni dona temperature po kan shia I can calculate the value of RE gas constant and ita 8.314 joule per Kelvin per mole okay and each one this is going to be the answer okay rate constant hemi le k2 le k1 ka shia chuanin I can calculate the value of activation energy okay simple as that next question akalang okay now which plot Arrhenius equation atangaron kal thau Arrhenius equation atangaron kal tamriu me you see which plot of ln k versus 1 by t is consistent with Arrhenius equation you see another form tunakanin okay see two forms of Arrhenius equation ka ziak to another form can represent le thaidan chumo Arrhenius equation ni the point can represent thaitan le let's see in terms of ln k is equal to ln a the slope is going to be ea by r okay rt I can make it 1 by t this is another form of Arrhenius equation and what can I have this is a straight line equation straight line I think a straight line equation and this one if it is y this one like 1 by t is x okay x and this one is going to be the intercept intercept anidona intercept this one apumpu hi minus a by r hi it is going to be the slope which is going to be m slope condition it's going to be like this y is equal to mx plus c mx minus c okay y is equal to slope is going to be minus m slope is going to be minus m okay straight line equation kakanai thaitani y is equal to mx plus c kakanai thaya but the slope is going to be negative slope in negative ani chon ang tian yang slope in negative ani chon see any equation ni option 2 le 3 le 4 rian taila a straight line ki slope ki negative ani yam a slope, they all represent a positive slope. 2 yung positive slope represent 3 point positive slope, 4 point positive slope. At san chua chowek. Oh, negative slope means it's going to decrease. Oh, the slope is going to decrease. Negative kan tichuan sign convention and negative kan tichuan decrease kan soy na tro. Slope he equal to minus EA by R we're having. Okay, let's see. Y I ngay ka zete lon ke X I ngay ka zete 1 by T. Okay, and slope is going to be negative. Slope is going to be minus EA by R tro minus EA by R kan. What is going to be the intercept? Intercept is going to be ln A. Okay, and this one is going to be the correct option anyway. Just seeing from the slope. Intercept po het apo intercept intercept 0. Okay, it have some intercept. Okay, as simple as that. Oh, can het yamang tro. This is another form of Arrhenius equation. Oh, we can make it like that also. Hey, look how long don't I think any down. Log K is equal to log A minus EA by 2.303 R T. Oh, in terms of log actual kitty can represent that here. Oh, log K low plot taila, the same thing we are going to have. A slope akan minus EA by 2.303 R kin that don't in any. So let's go to next question. Oh. You see, a plot of osmotic pressure pi versus concentration for a solution gives a straight line with a slope this much, 25.73 liter bar per mole. The temperature with the osmotic pressure measurement is done. Temperature osmotic pressure temperature can measure a formula osmotic pressure to pi is equal to CRT. We know that pi is equal to CRT, okay? Osmotic pressure, this one is osmotic pressure is equal to CRT. C is the concentration of the solution, R is the gas constant, T is the temperature. And the plot of osmotic pressure versus concentration gives a straight line, okay? Oh, straight line, slope is slope here, positive, slope. We're going to have like this. Plot of osmotic pressure versus what? Concentration. And the slope is going to be positive, okay? Give a straight line, slope is going to be, and its own positive slope and its own is going to increase, okay? The slope is going. And the slope, what did we have? Y throw, C, X, and eta. Oh, this one is going to be the M, is the slope, tinani, slope is equal to RT, tinani, oh, RT is equal to slope, okay? What did we have? And this one is going to be the slope equal to RT. We're having like this, okay? Let's see. And it's right there. Slope value can examine impact. Slope value 25.73 min petro. Time 25.73 titayla. Okay. Unit po kizi akong unit po liter bar per mole. Liter bar per mole. We're having like this, okay? Slope. What about R value? R like in terms of ATM 10 in terms of joule per Kelvin po in terms of calorie po R value in terms of bar like R value in terms of ATM or bar. And each one R value what I'm going to use is equal to R value 0.083 liter bar per mole per Kelvin. Kanay doon tatro. Slope is equal to R. T value ka chukan kalaw tro. At what temperature? Kanzon shotur kanitane. Kanzon shotur. Kiki kan sok chuan. Kiki kan solve chuan. What we are going to have? Let's see. T is going to be equal to 25.73 liter bar per mole. Okay, we're going to have like this. Liter bar per mole divided by 0.083 liter bar per mole per Kelvin. We're having like this. And each one bar and calculate liter. Mole inverse po in calculate. This one is going to come up. Kelvin inverse is going to be Kelvin temperature. If we solve this, what we're going to have 310 Kelvin current. So 310 Kelvin. Mas option how option sa yan Kelvin na impelotro Kelvin na impelwa degree Celsius in exam ni don. We know that Kelvin is equal to 273 plus degree Celsius. Okay, and it's only degree Celsius kini don degree Celsius aka convert in. We know that it is going to be k minus 273 kini don k minus 273 ni ang tro. See, it is going to be K minus 273, yes. And it's on Kelvin and Zai can move 310 Kelvin can move draw. It's going to be 273 draw. It's going to be 273. Oh, and what is going to come out? Around so to 310 minus 272 is going to come out 37 degrees Celsius. Okay, 37 degrees Celsius. As simple as that. Oh, can hit him draw, can hit him, can hit him. Harom low draw. Temperature zong chok ro min tia slope value min pe enge slope chuang ti ni don rt ki slope ani ti kan khathaya slope is equal to rt kan tia from the slope value min pe we just can simplify like that. Okay, next aka lang okay, a compound X contains 32% of A, 20% of B, and remaining percentage of C, then the empirical formula. Ito yung kanti person empirical formula kan zondon chon mo person he will take it in terms of grams. Okay, person he gram in kan lang. Okay, ano ito kan don how we should do the first step first step yang step in dotted first step in number of moles kan zong chuang number of moles number of moles of A, number of moles of A, number of moles of A kan zong chuang A le B le C kan ne tro a compound akian A le B le C kan ne ya enti empirical formula enge a subscript enge ron chok don enge subscript ron chok don chu kan zon chok tur chu ni ta number of moles of A ke enti ni don will is the 32% of A 32 divided by what is the molar mass atomic mass. Okay, molar mass, atomic mass, whatever is 64. Okay, 0.5 aron shock pero 0.5 aron shock doon ano ito NB kaningan ni doon NB po will take it as 20 grams. Okay, this is going to be the given mass. 20% of B is going to be the given mass divided by 40. 40 is going to come out 0.5 tau ni 0.5 tau 20 40 chan va to 20 ni NC ke ni doon you see NC here then 32%. 32 plus 20. Okay. He L B combined kania. Person ka dijon zazela anita. It means 100 minus this one is L B combined A plus B. Zazela. Person ka dijon zazela dita za minus 32 plus 20. What did we have? It is going to be 100 minus 52. It's going to come out 48 and 48 around chuang. And C akianin the mass of C ki 48 kamang theitina ni chu you see A B min pe C min pelawa A B ka percentage 32 le 20 le 32 le 20 zazela abang zong hachu it is going to be the C value. Okay, and it C value chu I can make it 48. What is the molar mass of C is going to be 32. Okay, what is going to come out around chok to 1.5 around chok 1.5 second step chu I think ani don second step chuan na a ratio okay nge kan cho chu NA is to NB is to NC we are having 0.5 is to 0.5 is to 1.5 kan nei draw kan nei like this we are having. Okay, but empirical formula chuanin ABC a subscript ka whole number om tur kha ni ta ni fraction in om theilawa hey A 0.5 B 0.5 C 1.5 ka ti theilo fraction in om theilo fraction in om theilawa it have to be empirical formula chon ani chon whole number ka convert don choi te ka ti thin ka I will just divide it money zinga number te ber hi nge 0.5 te ber draw 1.5 te. So I'll just divide 0.5 divided by 0.5. Let's just do it here. 0.5 is going to be 1 draw. Tapos smallest number can divide out 1. 0.5. The divide one is going to become out 3 year on so draw 3 year on so 1 is to a kan ito and L and B 1 is to 3 kan ito. Ano ito empirical formula ni doon, it means A subscript 1, B subscript 1, C subscript 3, A, B, C, 3. Tina niyan? A, B, C, 3. Tina tro. A, B, C, 3. Tina. It's going to be option 3. Okay, it's going to be option 3. As simple as that. Okay. Next, kalang you see. Consider the following reaction in a sealed vessel at equilibrium with concentration of N2, O2, then O gives this much. Okay, concentration at equilibrium in pair, concentration at equilibrium in pair, a reaction in pair, and a genre minti. If this is the concentration of NO is taken closed vessel. What will be the degree of dissociation of NO? Degree of dissociation of NO is genre minti. Degree of dissociation 20 nang how much fraction is dissociated from the tinan cheng zakan he cheng somma ka man chon ka degree of dissociation chu somma tinan mai ka thil phalle phallo ka man tamzat kha reactant in product siam nan a reactant khan exam nge an ne tang khan a man two more lo ta se reactant khan exam nge one let's see how we are going to do. Degree of dissociation, so it is given by, let's see, number of moles dissociated, okay, dissociated divided by, initial number of moles of reactant, okay. Number of moles of reactant dissociated, initial moles of reactant, okay. Initial moles of reactant we're having like this. Number of moles of reactant dissociated divided by initial moles of reactant. This is the formula. And it's I think suppose let's say initial moles of reactant. Okay, I'll make it from the equation. Reaction kiziyak put ang a reaction kiziyak put na ila 2NO gas gives N2 gas plus O2 gas kan na ito tiyan kan na ya. Ito kan tutin. This one is coming from the chapter equilibrium chapter tangaron kalaniya mo. Equilibrium chapter chemical equilibrium achon mole method mangin kan chokthina. Number of moles kan ti mole method kan chokthinta ni chemical equilibrium if you remember number of moles. Masa equation na hian hata hian mo aron pekhi. Number of moles zong nilawin a concentration zong in N2 te O2 te NO te a concentration zong aron pea. A concentration zong in a pair. So we'll just use number of moles in concentration of the reactant dissociated divided by initial concentration of reactant kantiyang. You see, at T is equal to 0, reaction line turn low, take up between reaction line turn low. If C is the concentration of NO, okay, if C is the concentration of NO, in Lulu, allow luck, then takin. Number of initial concentration of reactant, I will change it to number of concentration of reactant dissociated yang as a particular question based on concentration ng zone meron kaya initial concentration of reactant. You see, ito yan doon. At equilibrium at at equilibrium. Reaction line can lower, only the reactant will be there. Product alay form long, it will be 0 kan tintro. So equilibrium at exactly react ang si. A zong na react down low, equilibrium man ikat. Hey 0 ni tayo. 0 a zong na ni tayo. A zong na react tayo. Equilibrium man ikat. bang kha lom don katina ni chu ani chon exam way in react see number of concentration let's make it alpha hey number of concentration of reactant is alpha initial concentration of reactant is C tro C initial concentration of reactant C ani chon exam way in react kan ti chon mo number of concentration see atira tang hianin C kan tianga in react that to chu anei zong tang hian exam way payang anei zong chu C ani ta tro anei zong tang hian exam way in react ang C alpha khani don C alpha you see hey cross multiply so number of concentration reacted exam here uptake hazard is going to be C alpha okay is going to be like that okay C minus C alpha ane zong atang kan exam in react C alpha ane zong ka cheng za ni ta se are ka somnga ni ta se cheng za minus somnga ni me atira cheng za ne ya C cheng za kan ni ta se posa cheng za somnga manga za minus somnga ni me you see ane chon you see what is the stoichiometric coefficient 2 2 is to 1 ani em no le 2 in carry 2 is to 1 tro ani cho C alpha is going to be 2 chan ve chu 1 ani tro 2 chan ve chu 1 no hit 2 ani a stoichiometric coefficient n2 chu 1 tro 2 chan ve it means 2 moles in 1 mole pe C alpha pon exam nge pe kang C alpha divided by 2 kan tiang okay C alpha divided by 2 kan tiang heta po nge niang 2 moles is giving 2 moles of NO is giving 1 mole of O2 C alpha is also giving C alpha it depends upon the stoichiometric coefficient C alpha chan ve po half into C alpha ni ta tro it means C alpha by 2 tina C alpha by 2 okay 2 chan ve chu 1 ani C alpha chan ve po C alpha divided by 2 ani me half C alpha okay as simple as that ani chuan let's see we're having like this khati zong kha kan nei to chuan he kan koi so ta he kan hriat thei koi so ta kan hriat thei chu enge zong chuk ro minti koi so nin alpha value zong chuk ro minti the degree of dissociation okay alpha value ka te kan zon chuang hey alpha value kan shadu ete kan hriat dang you see I'm going to next slide okay Kc value how we are going to do Kc value ka kan hriat thei ni from this one Kc value is how much Kc value is the concentration of product divided by concentration of reactant raw is going to be the concentration of product divided by concentration of reactant is going to be concentration of N2 is going to be the concentration of N2 O2 divided by concentration of NO and itro and is going to be given the equation 3 into 10 power minus 3 N2 concentration 2 O2 concentration is how much 4.2 into 10 power minus 3 and what is the concentration of NO given in equation 2.8 into 10 power minus 3 and NO I'm sorry it's going to be square because the stoichiometric coefficient is 2 it's going to be square okay it's going to be square what is going to come out if we solve this one it's going to come out 1.6 around chuang 1.6 around chuang Kc value chu 1.6 kan nei ani chu ente kan man tang kai don hemi Kc value kan man tang kai dan tur chu Kc is equal to equilibrium kha en taila Kc concentration N2 ya he nge ka zia thai N2 I hian ka zia thai chu C alpha divided by 2 O2 I hian nge ka zia thai C alpha divided by 2 NO I nge ka zia thai C minus C alpha okay let's try to utilize this one C alpha divided by 2 ka zia thai N2 ya C alpha N2 ya C alpha divided by 2 ka zia thai tro O2 ya po C alpha divided by 2 ka zia thai tro NO2 ya NO ya ke ne ka zia thai C minus C alpha ka zia thai tro C minus C alpha ni dona but it have to be square tro square ai dona let's see ani chon Kc ya ke ne ka zia thai Kc ya ken what did we find out 1.6 ka zia thai tro ani chon C concentration you see concentration ka nga NO ka initial concentration C is equal to 0.1 mole per liter okay C is equal to 0.1 mole per liter C is equal to 0.1 mole per liter hey it is given equation 0.1 mole per liter of NO is taken initially the concentration is 0.1 mole per liter okay Chenro is going to be 0.1 mole into alpha divided by 2 into 0.1 alpha divided by 2 and yang draw is going to be C minus C alpha square. I don't draw. I don't is going to be a numerator here can multiply together 0.1 alpha square and yang draw. The same thing is going to be square. Okay, it's going to be C minus C alpha holding square. Okay, it's going to come out like this. It's going to come out like this. And it's what we have to do? Alpha value ka conjunction do patro. How to remove the square? And we have to remove the square from the right hand side. Okay, taking square root on both sides can be draw. If we are going to remove the square, taking square root on both sides, and it's next step two next step two. Taking square root on both sides. After this, if we take square root on both sides, 1.6, okay, 1.6 square root, 1 by 2 m or square root m or whatever, okay. Hey, put again it all, 0.1 alpha divided by 2 divided by C minus C alpha, okay, square, okay. 1 by 2, okay. Taking square root on both sides, okay. After this, taking square root on both sides. On both sides, we're going to have like this. And each one, the square root of 1.6 is going to give 1.2. Okay. And each one, this one square is square it can be cancelled. Square root it can be cancelled, and it's going to be 0.1 alpha divided by 2. 0.1 alpha divided by 2. Into, if this one comes up here on Solchuanin, we're going to have C minus C alpha. Kami yang draw. C minus C alpha here on Shogdom. Ganit here lang. It's going to come out like that. And if you control that, C minus C, I'm sorry, I still keep it. I'll make it 0.1, okay, times 0.1. C stands for 0.1, okay, 0.1. At a point 0.1, 0.1. A point 0.1, okay, 0.1. Kan siya kadaw nga. We're going to have 0.1 alpha divided by 2. This one is coming up 0.1 minus 0.1 alpha. Okay, we're having like this. And each one, this implies that 1.2. I can make it 1.2 into 1.26. Okay, 1.26. 1.26 into, I'm sorry, 1.26, I can make it 1.26, 0.1 alpha divided by 2 into 0.1 is going to be 0.2, okay, 0.2, 2 into 0.1 is going to be 0.2 alpha, and draw like this we're having. Aron shock empty here, aron shock draw. And it's on, let's cross multiply. I cross multiply 1.26 into 0.2. What is going to come out? 1.26, 0.52. Direct in kasi may hem cross multiply 0.52 aron shock 1.26 into can multiply 1.26 is going to come out minus 0.252. 0.252 alpha is going to be 0.1 alpha become like this is going to come out draw. Adik draw 1.26 let me cross multiply is going to come out like this, okay. You almost get the value of alpha. I try again, 0.252. is equal to 0.1 alpha. If this one comes to the right hand side, is going to be 0.252 alpha intro. 0.252 is going to be common. Alpha is going to be 0.1 plus 0.252 become like this. 0.252. I'm taking alpha here. I'm taking alpha common. Okay, I'm taking alpha common. And it's right here again, 0.252 alpha, if we add this together, is going to come out 0.352 on Chongtro. And it's alpha is going to come out 0.252 divided by 0.352 on EM. 0.252 divided by 0.352, it comes out to be 0.715 karon Chong. Oh, 0.715 karon Chong. Check him out, nothing is difficult. Okay, and what is going to be the option? Option is going to be 0.715. Oh, it's approximately 0.17. Okay, this is going to be the answer. Oh, it's going to be the answer. As simple as that. Next question. Okay. The rate of a reaction quadruples when temperature changes from 27 degrees Celsius to 57 degrees. Calculate the energy of activation. Okay. How many from which chapter is coming? This one is coming from chemical kinetics mini. Oh, chemical kinetics we have to calculate the energy of activation using Arrhenius equation. Bukhanin kamzong leang. How we have to do? How we have to do? You see. One of the form of Arrhenius equation, look, K2 by K1 can draw. A by 2.303 R is going to be 1 by T1 minus 1 by T2 can draw. We're having like this, okay? And yet the rate of reaction quadruples and each one it increases 4 times. It increases 4 times in a quadruples T2 quadruples equal to it increases 4 times. So 4 times in the increase. Okay, into 4. It increases 4 times. Okay. And each one in rate of reaction. You see, rate of a reaction quadruples at each one. If R increases to 4R, K will also increases to 4K. Tina. Not here, K will also increase to 4K. Okay. Ang natingnan rate is directly proportional to rate constant. Okay, rate law. The rate of reaction is directly proportional to the rate constant. Okay. If the rate of reaction increases quadruples 4 times, the rate constant will also increases 4 times. Okay, because they are directly proportional to each other. And each one log K2 by K1 and each one. Let's make it this one. As K low detail K1 the value let's make it X. This K1 value X low detail. If it increases 4 times quadruples, and the is going to become 4x and the M X into 4. Okay, it's going to be 4x. Increases K2 increases 4 times. The rate of reaction quadruple with temperature increases 4 times. This K2 corresponds to T2. K1 corresponds to T1. If the temperature increases, the rate constant increasing 4 times. Okay, as simple as that. A by 2.303 R. R here again, 8.314. 8.314. Mangro minti. You need to choose here. Đúng không? What is the temperature is given? The temperature is given to be 1 by T1. One by T1 minus 1 by T2 is going to be 270 plus 27 is going to be 300. In terms of Kelvin, 327 in terms of Kelvin it is 300. Okay, minus is going to be 273 plus 57 degrees Celsius. It is going to be in terms of Kelvin. It's going to come out 330, okay, 330 Kelvin. It's going to come out like this. X and cancel. Log 4 comes out, is going to be 0.60, okay. And each one, if we calculate this direct in, and each one, let's see. And each one, we can have like this. 2.303 into 8.314. One by, if I take the LCM, if I'm going to take the LCM, 300 into 330 is going to be 330 minus 300 and the M. Like this, we're going to have like this, we'll be having, okay. 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 And which one we done? We can have like this 0.60 equal to EA by 2.303 into 8.314, okay, into 300 into 330, okay, it's going to be 330 minus 300 is going to be 30 so we can have like this if we simplify you just try to do, okay. I'll just write the answer directly. Here comes out to be, if we solve this one, if we solve the whole thing, a value can a vector, here comes out to be 37.911 kilojoule per mole. Aron suang kilojoule per mole. 37911 kilojoule per mole. Okay. Which is approximately equal to 37. If we round off, it is going to be 38.04 kilojoule per mole. That means option 2 is going to be the right answer. Shit, I'm not wrong, ma'am. I'm not wrong. Just in formula I apply, don't take shit according to the given question. Okay, let's go to the next question. The work done during reversible isothermal expansion of 1 mole of hydrogen gas at 25 degrees Celsius from pressure of 20 atmosphere to 10 atmosphere is how much work done during reversible isothermal expansion? Work done during reversible isothermal expansion. Okay, during isothermal process, between work done formula 2. If it is reversible, one thing, a question here in pressure, pressure mean pressure. When the data of the pressure is given, pressure data mean action more, we have to use the formula 2.303 nRT log P1 by P2. Okay, we use this formula log P1 by P2. Log P1 by P2 kan mangang. Pressure is given. Suppose antina a question here in hey volume milo petajok ta se reversible work done 2 minus 2.303 nRT log V2 by V1 and P1 by P2 V2 by V1. Volume data milo peta se question here reversible work done 2. I will apply this formula. But for this particular question, I mean question big mean pressure come in pair to bang formula like apply. Okay, let's try to apply. Any irreversible work done low data say irreversible and each one in WIR is equal to minus P delta V khan metro. You just apply this formula, okay? But for the time being, the question is asking the work done reversible. Oh, when pressure data is given, when pressure value is given. Let's see. Let's try to do. W reversible is going to be minus 2.303, and value how much? Work done, 1 mole is going to be 1 mole. Draw is going to be 1 mole, okay? Is going to be 1 mole. Ani chon R value hi exam ya mang roti R value khai ta chon mang roti chu R value khai 8.214 da kan mang thai dei lo mang roti ang kan mang mai ma is going to be 2.0, okay? Just write the values. Temperature to how much is given? 25 degrees Celsius in terms of 2.0. Let's keep the unit position. Calorie per Kelvin per mole and our value. Temperature to how much? Temperature is going to be 225 degrees, 273 plus 25 to 298 Kelvin. We're having 298 Kelvin, okay? Into log P1, how much is given? P1 is how much is given? P1 is, this one is going to be the P1, okay? This one is going to be the, from pressure. Yeah, pressure is decreasing. Pressure is decreasing. Then means expansion. Pressure is inversely proportional to volume, okay? We know that pressure decrease. Pressure decrease. That means pressure is going to be 20 divided by 10, okay? It's going to be log 2 AM, log 2 current shock theater. Log 2 on shock theater. Now if we calculate this, hey can solve John, log 2 to how much value? Log 2 is having 0.30. If we solve this, what is going to come out? Minus 13.14 calories around shong. Calories around shong. Per Kelvin, calories per mole around shong. Calories per mole around shong, which is going to be, minus is going to be option 3, minus 413.14. Okay, as simple as that. What formula I have to use? Pressure data bin pair work done reversible. Minus 2.303 nRT log P1 by P2. Okay, volume impact one log V2 by V1. Irreversible means also in minus P delta V can what I'm saying. Okay. Next question. Did I miss something? Okay. Okay, that is the last question, Anito. Mass in grams of copper deposited by passing current can pass cathode copper and deposit donor. Okay, hey let's see. Copper ka exactly cathode copper rota can in deposit don in zotina nikio. Hey question let's say it is given. Let me write the full reaction, the full cell, a full cell ki means like let's say this is a galvanic cell kanitani. Galvanic cell, this is the voltmeter, this is the voltmeter, okay, voltmeter. I'll write the full cell ki it's better to understand. You see, this one is the copper rod. This one is the zinc rod. Let's say this is Daniel cell. It is an example of Daniel cell too. It is an example of galvanic cell. This is NIELL Daniel cell. It is one of the types of galvanic cell. Okay. What we are going to have? We are going to have the Tahyanin zinc sulfate solution, which is going to Zn2 plus SO42 minus and ionize. The electrolyte is going to be the zinc sulfate, which is going to ionize Zn2 plus SO42 minus. Whatever, copper sulfate copper sulfate is going to ionize into Cu2 plus SO42 minus. Okay. A question in this This is the complete cell. It talks about cathodic reaction. we call this side, you see, Cu2 plus le SO4 2 minus he can compare here in, let's see, can compare here more. Which one is electron deficient? Kung electron natrium zok. Yeah, electron natrium zok. Cu2 plus electron mamotro, electron deficient, so it will go and collide. Rot men yan and collide anga. Rot men yan Cu2 plus yan, rot yan collide anga. Rot atang yan electron alak sakang it's going to take 2 electrons from the rot. Okay. 2 electron alanga is going to form Cu solid form. This one is coming from the aqueous. Cu2 plus. And it was Cu solid form. To Cu solid form, it will be deposited. Hey, apang vela here in Cu ka solid angin ay deposit down ni chu ko so nga minzo copper deposited atilay actually like Cu copper deposited sulay chu ni minzo centro. Let's see. Adang chu electrochemistry class soi thui na chu ga soi zau tak tak na chu ga soi don yo tun question b ka chuan in min zo chu exam nge copper ki deposit ang ati ni ma se chu ta po chu ning ting kan ti don. You see. Electron copper pakat Cu2 plus pakat yan electron pahizel amamota Cu2 plus pakat Cu2 plus ions Cu2 dipositive ions pakat yan in electron pahizel amamo copper atom siyam turin chumi ka chu copper atom chu solid ka ay deposit ka copper atom pakat siyam turin 2 electron zel amamo tina at siyam tro reaction na tangkian mo chu electron chu khoi tang mu chu electron mu na chu rot atang hian mu rot atang hian ai kolai ta katika ai kolai ta rot atang hian electron lak saka let's see a question om zia dai shit thiam hi a poi mo lu tu ga thil tam tak kong ro tam tak hi a su thin kan understanding is going to give this one is from aqueous tu ya tang khan electrolyte Cu solid so ta ka zia so you see how much electron charge pakat hi exam nge kha 96500 coulomb tro 96500 coulomb kan tia electron charge pakat chu electron charge pani electron hi oma 2 into 96500 ni mayang tro like this pakat chu ni 96500 kan tel chu pani chon 2 into ni maya ani chon hey exam nge 1 mole ani Cu2 plus hey 2 electron 2 moles of electron hey 1 mole of copper 1 mole of copper ri na chu exam nge kha 63 gram per mole ani molar mass of copper chu you see 1 mole ani 1 mole of copper is equal to 63 gram per mole chu ye omzia this much charge this much coulomb kan thai chameng space om lo ma you see in lo screenshot mo and du khan choi lo le me don yo ka thai chet poi sorry okay Ami here in kan ti dam tur chumo 2 into 96500 charge deposited how much copper exam na deposit how many 2 electrons here in 63 gram a deposit ani 63 gram per mole okay 63 gram per mole a deposit ani le question ken ngam min zo tak ti khan khati zong kha chu let's say a chiang in ka sia question ngam min zo tak alo current kha hela electron ni khoi trai ni ala ka di kha copper rot atrai na la tro kha copper rot atanga electron la lo kha in he ta current anno ta tang khanin current kharon kalta ni through the voltmeter voltmeter lempo ka zia kha current kharon kala kha current ron kal zat kha khoi som khen min pe chu ngam zia you see hetlai electron hi copper rot atanga la khanita copper rot atanga electron la khan exam nge 63 gram per mole of copper kha pe copper rot atanga electron la lawin he ta anno atanga oxidation ina electron a release atanga current ron kal kha hey question given chuan itani chu chuan in exact nge copper a deposit veang anot atanga current ron kal khanin I mean electron ron kal khan ti zok current chu cathode atai anot a kal zok chuan anot atanga electron ron kal khan exact nge a deposit veang atina ani chu dermaya like this how we are going to do Charles formula kha Q is equal to current into time. Okay, current into time. Q is equal to current into time. Exactly current impact question akian. Question akian. How much current? Yes. 96487 ampere min petro. 9.6487 ampere min pe. Into time exactly time 200 seconds ani tro 100 seconds ani. 9.6487 ampere into second. Okay, how much is going to come out? 964.87. Ampere second current shock dona. Ampere second current shock. This is going to be the amount of charge. How many amount of charge here in example copper deposit veang pi min zot ani chu question. How many zat here in copper 63 a deposit ti kan khato. Here in example deposit veang. Ampere second is equal to coulomb. Coulomb na yang rang. It means 964.87 is equal to coulomb. Tinani may. Ampere second is equal to coulomb. Whatever. Ani chuanin 964.87 coulomb. Charge. Hey, how many charge here in 63 gram deposit comes here? 964.87 charge will deposit. Okay, will deposit how much? Ani chuanin. How we are going to do? Kantinam turchu is equal to 63 divided by unitary method ang kani mayo. Is going to be 63 divided by this much charge. 2 into hey kan hit sa kani kan hit law ka kan zong chok dona. 96500 coulomb into this one is gram, okay? Into how much? 964.87 coulomb, okay? Coulomb and cancel lang. What is going to come out? 0.315 gram. Achona kachua chotet kachulo chokte vetola. Chotet kachulo tinga 0.315 grams karon chong. 0.315 grams. As simple as that, okay? Nakina electrochemistry class ni dang ka class in le tem ni chon hai achiang jogging kan soi zawang tu na chon question chan na ngor hi kan soya du top phodang ya khat zong kham ya question som pasari physical chemistry ta ron culture. Yeah, thank you.